In this episode, we're going to do some production coding. We're going to start with what we did in the Rust Axum Full Course and scale it up to a production web application code base. We will have 9 chapters from tracing, config, and model layer with PostgreSQL, and then we will code password encryption and secure web token, and end with a JSON-based RPC. You can find the GitHub repo and more information at awesomeapp.dev Rust web app. All chapters have their corresponding Git commits, and we will also have key visualizations of our code design and progress. This is the beginning of the Rust web app production blueprint episode series. It's going to be dense, but pretty cool. And by the way, big thanks to CRUD Nebula for their sponsorship. And also, I'm trying to go full-time on creating Rust educational materials for production coding, so any help is big help. Okay, with that, let's get started. Okay, so our first chapter is going to be the baseline. So what I did is I took the Rust Axum Full Course that we have, and I trimmed it down and reorganized a little bit the code to make it scalable from the get-go. So it's really bare bone. So what we have on this first commit here, which is going to be the 01 baseline, is this source code, which is going to map to this architecture. The first one that we have from the top is the web layer. So that is all the files that we have, more or less, from the Rust Axum course. I moved the route static inside the web module. And then in the web module, I have the on error here, which is the only errors that knows about the Rust Axum into response and so on. So one thing which is important when you structure your code is you don't want to have one big error for everything. You want usually to have the main modules having their own errors. And then you can bubble them up as it makes sense. Then we have our context, and here we have our own error as well. And it's going to be a relatively simple here context for this example, but in future episodes, that is going to grow quite a bit. And the context is the information that you get from the request or from anything that identify the user and a request context, regardless of the web framework you are using. So that is a nice decoupling. And then we have our model layer. And right now it's very basic. And I reorganize this such as we're going to split the model managers, which is going to be for the state, like the database pool, and the model controllers that we're going to implement, which is going to have the CRUDs and other methods per entities. So that is going to be a relatively scalable model. And the model layer will have a store. Right now it's going to be very lightweight, but eventually you can have store libraries or utilities that you might find. And our model layer will use SQLX and even SQLB, which is a little lightweight SQL builder based on SQLX to talk to the database. And then I move the log logic into its own module. And right now there is no error, but eventually that might grow into more code and have its own error. But right now it's relatively simple, so we keep it like that. And then we have our main error and our main.rs. If we go to our main.rs, I did some cleanup, so we have our model manager now. So we initialize the model managers, which will be our app state in a way that will hold the database pool connection. And then we will give the model manager to our model controllers. We're going to see that later. Then we're going to have our route RPC, but that will be for later. So I remove all of the APIs because we're going to use a JSON-RPC scheme here. And then we have our routes all that define our middlewares and our routers. And in fact, if we take it out, we can visualize a whole request flow. So in Axum, you have 2 kinds of constructs. You have the middlewares and the handlers. So the static here is what we have as a fallback services on the served dir. So that is a handler that we have there. So that will take care of the static file serving, and we're using the served dir library for that. Then from the Rust Axum Full Course, we get our API login. We'll do logoff later. And that is what we have over there. And right now is a fake login. We don't have password encryptions, and we don't have anything. It's just a hard-coded one. Very simple one. And that is what we're going to do in this episode with full password encryption and secure web token. And then what we have is the API RPC, which was the API REST that we have before. And that is what I commented here. So this code is not active, there's no implementation, and that is what we're going to do in the chapter 9. Now, one thing that we carry over as well is our response map, which is over there. And that is very important because it does the remapping of the error messages to make sure that we send only the minimum information to the client, as well as our request line log, which is critical when you do a production application. You want to have one log line per request that is very rich in context. And we also have our middleware, which is our CTX resolve, which basically resolve the CTX for a given request. And right now, again, it's kind of fake resolve, but there's a placeholder, which also takes the model manager as a state. It's important to note that the Auth resolve will get executed for both paths, for the API login and logoff, as well as the API RPC. So the Auth resolve is infallible, meaning that it will not fail. It will capture the error and put it in the request flow, but it's not going to fail. And then we have another middleware, which is the Auth require, which will add to the routes RPC, like so, and it will fail the request if there is an error. So the Auth resolve gets executed either way, and then when it goes through the path login and logoff, if it fails, it doesn't really matter. And then if it goes to the path API RPC, then the Auth require will fail the request if it didn't succeed. Now, in our case, it's not going to be fully needed because our handlers on the API RPC are going to require the CTX, so they will fail no matter what. But it's always a good idea to have the Auth require in front of the routers that you want to ensure they have to be authenticated. Now, also, the next thing that I've done is I moved the quick dev into the examples. Kind of works better on Windows. I think there were some issues on doing a cargo test and cargo run in parallel. And as well as it's a better fit in the examples anyway, because it's not really about unit testing. It's about just a little helper to just develop fast. And we're going to write quite a bit of unit test in this episode. So this way, everything is very intent driven, has the right places from the get-go. Now, one thing I've created as well is a web folder which will hold the index.html. So that is just a hello world. And we will put this path in the config such as it can be used in a real deployment. Now, if we look inside our quick dev, we're going to see that we have our HTTP test and we're creating our client with our local host. We're doing a GET request on index.html and then our fake login here with a username and password, which is demo1 welcome. Now in the README, I put the instruction for the two different terminals. So what we can do is take terminal 1 that will do a cargo watch on the source folder and will execute run. And so this way we have our server that runs, and every time we change the server code, it will rebuild and restart. And then to test the client side, we have the other terminal, which is going to do a watch on examples folder and run the example quick dev. If we do that, so we can see that we have our get index.html. And then if we scroll down, we have our response body. And then we have our post on the API login that set the cookies. And again, this is fake, but in this episode, that will be the rare thing. And then we have a simple response body here, a success true. Now, if we look on the left side, which is our server, and map it to our request flow, we can see that our mctx resolve, that is the Auth result over there, which is our CTX resolve. We have the API login handler, which is this handler. And then we can see that we have our middleware response map, which allows us to have our request logline. So already this code, this baseline is already pretty well set up to scale. So that is going to be our baseline. So in the following chapters, what we're going to do is we're going to do the full login and logoff with password encryption, the full Auth resolve with token validation, the RPC layer with our Auth require, and then we're going to augment our response map for our request logging. And to do that, we're going to build a scalable model layer with model manager and model controllers and their unit test that will talk to a Postgres database. So it's going to be a pretty big session, but a pretty cool one. So in the second chapter, we're going to add tracing, just the basics. So for that, we're going to go to our main. And first, in our cargo.ml, we're going to add the tracing library. Make sure to add the env-filter feature because we're going to add it to configure our filter. Now in the top of your main, you are just going to add the tracing subscribers like that. Now in my case, I put without time because otherwise when I do the video, the tracing lines are too long. But that is probably something that you don't want in your code because having the time is useful in normal tracing. Then I have a personal preference where I don't need a target, but that again, this is just a personal preference. You might display the target. The important thing here is to configure it with the event filter environment variable. So you need to make sure to import the env-filter from the tracing subscribers library. And so the goal now is to set the environment variable. Now there's a nice little trick in Cargo where you can define your .cargo config.ml. And that is a config for all of the cargo commands. And within this file, you can have a section for your environment variables. And so in this case, we are going to define Rust log with our Rust web app, and we're going to have debug. So this way you can filter exactly what you want. Now the Rust web app has underscore. So if we go to the cargo.ml, we see that our name is Rust web app with a dash, and the convention here, that becomes underscore for the filter. Another strategy will be to use a .env and use a .env in the application code to set the environment variable. But what I like about this config.ml is that the environment variable are set outside of the application by the container in a way. So in this case, the container is cargo. And when we're going to deploy that into a Kubernetes, the container will be Kubernetes. And that will be the config map and the secret. So this way, the environment variable are set outside and before the application run, which is usually what you want in a production application. Now, if we go back to our main.rs, and we're going to scroll down into our server, we can see that we have our println. And this is a little best practice I have. For my debug prints, I usually do this kind of notation with a dash and 2 greater than. And usually I don't commit those. So those are temporary prints. And before I commit, I do a search on these characters to make sure that I don't have any println like that. Now in this case, I let them in because it was for the example, but now this is actually a good candidate to become an info tracing. So we're going to import tracing info. So we're going to remove those characters. And now we can go and do a global search for the println with these special characters at the beginning. And that will give us all of the println that have those characters. And we can replace it with our debug trace. And then that's it. So obviously we're going to have some compilation errors, but they are trivial to fix because it's just about importing the debug. Now in the middleware res map, we have another println that didn't have these characters, and that is a new line print. And so we're going to change it to debug as well. Now, in practice, this is not really useful because when you're going to have multiple requests coming at the same time, this new line won't have any meaning. But as we are going to do our developments right now, where our requests will be sequential, this is going to be a nice little trick. Now in a production app, you might want to remove that. That is kind of useless. And in fact, many of the debugs that you have, you might strategize to remove some are more for early development than anything else. So now you can do the same fix for all of the files. And so that is very trivial. And now another little trick is you can bring your README and we're going to add -watch and we're going to watch the .cargo folder as well. So now we can run that in our terminal. And we're seeing our info listening. And then if you bring your quick dev and press save on quick dev, then you have the nice tracing display with our empty line. Okay, so that was our warm-up chapter in a way. So for our third chapter, we're going to do our config layer. So first we're going to go to our .cargo config.ml, and we're going to organize this environment variable the same way that we'll organize it in Kubernetes files, for example. So we're going to have a section for config map, and we're going to call our variable service web folder. So the convention is to start our environment variable with service underscore and use snake case and uppercase for the name of the environment variable. Now, the value of our web folder is going to be relative to cargo to ML. In a deployment scenario, you might want to have absolute path in your Docker image, but that is a little detail. So now we can go back to our main. And if we go on top, my best practice is to have a module code section. And the way that I organize it is I have the submodule first, then I have the eventual re-exports. So that is the best practice that I mentioned before. I re-export the error of this module, and then I have my imports last. But that obviously, it's a personal preference. So what we're going to create is a module config, and we're just going to create a single file module. So that will be fine in this case because the config module is small enough that it doesn't have to have its own error, and it can use the create errors. Now, if we drill to the config file, we'll be using the create error and result. We're going to use the std environment, and then we're going to create our config struct. And for now, we're just going to have a section with our web folder. So in this case, we don't need to prefix with the service underscore. The service underscore is just for the environment variable, and in the config, we can remove them. Now I'm going to allow the non-snake case because we have screaming snake case in a way, all uppercase. But that is a personal preference. In my case, I like to see what comes from the config very quickly in my code. Now we're going to implement our config, and the goal is just to load from the environment, and that will return a result of config. And so it's going to be very simple. We're going to have OK, config. We're going to repeat the section, and we're going to have web folder, and we could do something like that, have var, and then service web folder. And then we could do an unwrap. However, you don't really want to use unwrap, and we don't really want to cascade back the environment error back to the main error because it might not have the right contextual information. So what we're going to do is create a function which is going to be getEnv, which will take a name, which will be a static string, and it will return the create error result string. And so inside this function, now we can have the var name, and we're going to map the error into our error config missing environment, and then we give the name. So now that we have that, we need to create it inside our create error. For that, we go to our error.rs, and we're going to just add this config missing with a static string, as simple as that. And one thing I like about my errors is I'm trying to put everything as enum early on. I can refactor the name later anyway, and then having simple properties. So now that we have that, we can take our env and do a getEnv, and now we don't need to have the unwrap anymore, and we can put a question mark. Now what we don't want is we don't want to load that all the time. Every time someone needs a config to have to reload the environment variable. So what we're going to do is we're going to implement a function, config, that will return a static config, such as we load the config only once. And the way you put things in static in Rust is we can have our static instance, and now we can use a once lock, which is new in Rust 170. So that is part of the standard library now. And that is the equivalent of once cell library. Now the way it works here is it takes one generic, which is going to be the type is going to store. So that is going to be our config. And then you do a once lock new. So at the beginning, the once lock is going to be empty. And so to get the content now, you get an instance and you have a function which is get or init. And then it takes a closure and you can create your config there. And in fact, what we're going to do is an exception to our no unwrap rule, which is in this particular case, we want to fail very early if we cannot load the config. So we're going to do a unwrap or else, and then we're going to panic, and then we're going to do a while loading, and we'll give the cause. So the reason why you want to do that is because you don't want to have your application starting without the config being loaded. So it's better to fail very early, such as you can fix the issue, rather than having the application running for a while, and then you don't understand what's going on. So now if we look at it, the closure will return config. So the getter init, it will call the closure, and if it has one, it will return the static reference of it, and otherwise it will store it into the once lock and return the static of config as well. Now, static variables in Rust are not like const. Const is almost like a find and replace kind of things. A static is a full variable which has to have a static lifetime. And in fact, in this case, we have it inside config, but statics are always global. So we could, for example, put it globally, it will be exactly the same. The only reason why you put it in a function it changed the visibility of it. Now this instance variable is accessible only within the config function, even if is in memory is created globally. So both are the same. I like to have it this way, such as I can just have a name that makes sense within the function, and I don't have to worry about other conflicts in the same module. So now that we have that, we can go back to our main.rs. And one thing that I like to do is to re-export the config like that. So this way I can have use create config, just simple. That again, personal preference, but that is something I like to do. So we can go to our routes static, and now we can replace our const web folder by config. We import it, and then we do a web folder. Doing some reformatting, and then we don't forget to put the reference, because the web folder will be the string. We cannot take it out, obviously. And if we bring our quick dev terminal and we do a run or a refresh, we can see that we have our response body. And then again, the cool thing is because we have the wash cargo, if we change the environment variable, it will restart the server. Okay, so that was our second mise en bouche. And so now we can go to the serious stuff here of creating our database. So now let's go to chapter 4, which is the database and the library load, which is critical for fast development. And before we start with the code, let's do a quick overview of unit testing and integration testing. So when you have your service code, for example, this is our code, you write your unit test for most of the layers. You have some sort of unit test infrastructure within your code. And then you have your integration test that use a real database, Redis, Amazon S3, or whatever external services you are using. So today we're not going to write or talk about integration testing, but we're going to write quite a bit of unit test, which is very important. Even if at the beginning you write only some, is much better than none. So make sure to always start with some unit tests, and then you can grow them over time. That will usually help you iterate faster and have more robust code. Now on the unit test side, we have two strategies. One strategy is for all of these external services, we are going to write mock services. And in this strategy, everything is going to be contained within the same process. So when you do unit tests on model, for example, the model will talk to the DB mock. The catch of this is that now in your application code, your model has to know that sometimes it has to talk to the real thing and sometimes it has to talk to the mock. So that will cascade back up more or less, probably not all the way up, but there's going to be quite a bit of branching that will be happening into your application code. So the result of that is that typically this is quite intrusive into your application code. The second downside of this approach is that you're actually testing a code path that will never ever be used in production. So some of these code paths will be, but others won't be, and you will have to trust that your integration test will take care of this code path. But the great things about unit tests, and moreover the way they are done in Rust, is that they allow you to be very granular into testing private functions. And so we don't want to lose these benefits because that is lost when you go to integration testing. And also, most of the time when things fail is in between your program and the database or Redis. The other approach is to have your unit test infrastructure having the real Postgres database, the Redis, and an S3 service. And you put that in a local host or a local Kubernetes. And in S3, we are pretty lucky because we have Minio, which is a very good mock services. For S3, it's much more. You can use it for production as well, but it really follows the S3 APIs. So now when the unit test tests the model will actually talk to a real Postgres database with all of the intricacies and all of the details that matters to our application code. And obviously, it's the same thing for other services. So the complexity of the unit test on the service code decreased. Now it's much simpler on this side. Now on the unit test infrastructure, the complexity is going to be a little bit higher now because you are going to have to take care of initializing and starting all of these services and making sure that now your unit test environment can have these environments. But for our style of programming, that has a very big net value. So this is the approach that we are going with. Okay, enough talking, let's start coding. So first, what we are going to add to our cargo to ML is going to be SQLX. Make sure to add the features Postgres and UUID and time. This is what we're going to use later. And then we are going to create our first SQL files. So the way it's going to work is that we're going to be very iterative. And so every time we're changing a source file on our server, the database will get recreated from scratch. So the old one will be dropped and the new one will be recreated. Eventually, you want to have evolution. Some people are calling it migration. I prefer to call it evolution. We're going to talk about that in future episodes. But right now, it's going to be early on in the development stage where you can rebuild your database from scratch all the time. And that will be a good starting point to then after have a strategy of database evolution. So within our SQL folder, we are going to create a folder which is going to be dev initial. And the first files that we're going to create, and we are going to number them like that with a 2-number padding, is going to be our 00 recreatedb.sql. And if we get into it, we're going to be merciless on this one. It's going to be a brute force drop DB for the local database. Here's a little trick in Postgres to kick out all of the sessions for a specific username or database name. And then we're going to drop the database if it exists. And then we're going to drop the user if it exists. And then we're going to recreate them with hard-coded passwords. So those are just local host passwords, so they don't need to be encrypted or these kind of things. But the goal here is to be able to recreate the database, redrop it, and recreate it all the time, such as we can iterate very fast in our data model at the beginning of the development. The important point as well is that we are using app user and appdb. We are not directly creating on the Postgres default. And that is very important to do it early on. Otherwise, later, it's kind of a pain to refactor for it. So now if we bring back our SQL folder, dev initial, we're going to create a new one, which is going to be our 01 create schema.sql. And this one is the main one. And that will be executed as an app user. So we're going to have our base schema. And right now it's going to be really simple. User ID, we're using that, which is a new way of doing the big serial. And one technique that I like to do is for most of my tables, if not all, I always start the index at 1000. So that is an old technique that I have, such as I can reserve the previous IDs for internal tests or route users or system users or whatever I want. This is mostly a personal preference. And the important point on this one is to make sure that that is a primary key. And now we are just going to have the username right now. And then we are going to create another table, which is going to be our task. And that will be the ID, same thing. And then it will just have a title for now. In future episodes, we are going to make that much richer. But right now, we want to show the basics on how to do a scalable code, and then we'll add features later. And now that we have that, we bring back our SQL dev initial folder. And we are going to do another one, 02, and it's going to be our dev seed.sql. And that is just seeding the database with whatever we want for development. And right now, we're going to keep it very, very simple. We're just going to insert a new user for demo 1. And we're not even going to create a task. We'll do that in our unit test infrastructure. So in short here, we have 3 files. The first one will be executed by the Postgres root user to make sure that we can drop the database and recreate it. And then the 2 other ones will be executed as the app user on the appdb. Now, if we go back to main, we're going to create a specific module. And we're going to prefix it with underscore, and that is going to be our dev utils. And we're going to create it as a module file. And then eventually that will be used only for unit tests. Now, if we get into it, every time we have a mod.rs, the thing I like to do again is to have a code region, which is modules, and I'm defining my submodules. And in this case, we're going to define a devdb, which is going to be part of our dev utils, which is going to recreate the database. So we're going to get into it. And again, the goal here is to execute the 00 recreate DB with Postgres, and then execute these 2 in order with the app user on the appdb. And right now, what we're going to do is going to be very simple. We're going to split on the semicolon and just execute each block. So in SQLX, I've found a way to execute files, but it has to be statically named. And in our case, it's not about database migration or whatever. It's just about executing files the way that we would like to execute it. So that is why we're going to have to create it manually, but it's a good Rust exercise anyway. So we're going to use SQLX, pool and the Postgres. And then one thing that I like to do is create a type alias for pool Postgres. That is just a personal preference here. and we're going to hardcode the root Postgres URL, and which is Postgres welcome, and the app Postgres URL as well, which is going to be app user dev only password. So here is important to hardcode those passwords in a way, is because we never want by mistake to have this code run and erase stage or production or whatever. So if you hardcode them, then obviously it will fail in case it runs in this environment. And those are localhost passwords, so they are not really impacting anything. So we'll be using the dev app URL with this user to do the 001 and 002, and we'll use the Postgres URL with Postgres welcome to recreate the app database. Now we're going to have some cons for our SQL files. So that is going to be the SQL files that we're going to recreate the database. So we're just putting it there as one file. And then we're going to have the SQL dir, which is the directory of this file, which contains the other files as well. So the 00 recreate DB will run with the Postgres URL, and all of the other files in this folder we'll use with the app URL. So now the first thing that we need to do is obviously creating a new database pool. And we'll return a result of DB on SQLX error. So it will take the connection URL, and then we're going to do the imports here. And the duration is from standard time. Now we're going to create our first pexec, and that is going to execute one file. So it's going to take a database pool and then the file to be executed. And it will return a result of void on SQLX error. We're going to do a first version that is going to be very simplistic, and eventually in future episode I'm going to improve it if I still don't find a library to execute SQL files. So let's go into this function. We're going to do our debug print. We're going to use info in this case, and then we're going to read the file, and we can put a question mark because SQLX error actually has a from standard IO. So that's why it works here. And then we're going to split the file into this SQL section that we can execute with SQLX. And we definitely need to make the split more SQL proof. So if you have SQL functions or store procedure, it's not going to work very nicely. In future episodes, I will fix that. But right now, I just wanted to have something to work nicely. And now I do a for SQL in SQLs. So that will be our strings. And I'm just going to do SQLX, query, execute, and RDB. So SQLX can obviously execute one query at a time. There's a query many, but it doesn't really work with a full file content. So that is a way I found it to do pretty well. And now I can return OK. Now that we have that, we're going to make our function, which is init devdb. And that will return a result. And we're going to make the error very generic on this one, which is going to be a box of the standard error. So I'm not using anyhow because I like anyhow to only be available on my examples and my unit test. But for my application code, I prefer to be forced to be structured from the get-go. So in this case, because that is used inside my application code for now, I cannot use anyhow. So I'm using this workaround. Now we're going to do our debug print, and we're going to create the app database with a Postgres user. So we're going to have a let root DB. We're going to create our DB pool for root Postgres user. And now that we have that, we can do a pexec, the root DB, and our SQL recreate DB. And then that will be await. So that will execute the file. And because rootdb has full privilege on the database, I don't really like it to have it accessible later in the function. So rather to split that into his own function, I could put a drop rootdb to make sure that nobody can use it below, or another technique that I like, I just copy that into his own code block. So in this case, this code is copied with this block, and the rootdb will be dropped at the end. That is another way here that I like it. And I don't do that often, but sometimes when I don't want the variable to bleed below the function, this is a nice way to do it. Now we're going to get our SQL files. So we're going to do a path, vector of path buff, and we're going to the read dir of the SQL dir. And we're going to do a filter map of entry, and we do entry.ok and the entry path. And then we collect. With this way, we get a vector of the path buff of this directory. We could use a walkdir library or whatever, but since again, this is very simple, we don't have to be that fancy. One thing we don't want to forget is to do a path sort. And the reason of that is because they don't come up always well sorted, and we have all of the names very well sorted by design, such as we can execute it sequentially. So by doing a path sort, we're making sure that everything is sorted well. Then we're going to execute each of the SQL file. So we're going to have our appdb, and that will be our appdb URL. And we're going to do a for path, and then if we have a path from the string, we're going to replace here. This is a little hack for Windows, because in Rust, the good news is it supports /. But when you get the path buff as string, it will give the slash the Windows way. So this way, that works on both systems. And then we only want to take the SQL and obviously skip the SQL recreate. So we're going to say if path end with SQL. And if it's not our SQL recreate, we're going to do a pexec appdb and our path. And we could have put this condition into our filter map up there as well. Either way works. And then the only thing we need to do is to return the OK void. And that's it. We have our initdb. So it was quite a bit of work, but now it's pretty cool because we can recreate the database all the time. And the only thing that needs to be really fixed over there is this pexec when we are going to add function, which is again going to be in the next episode, and we'll make it a little bit more versatile. So now what we want is our init devdb. We want it to expose it inside the parent module, and we're going to create a function which is going to be initialize our environment for development. And it will be called from main, but again, this is only for early development, obviously. So we're going to make the function async, and it's going to be initdev. Now, one thing we are going to use is a once cell from Tokyo. So we're not going to use a new once lock, because a new once lock is not for async. And because we have some async function to call, we need to have a once cell that supports async closure. And that is what the Tokyo once cell does. So now that we have that, we can follow the same pattern, and that will be init. I don't call it instance because in this case, it's just going to be a once cell of void. So I call it init. And the once cell from Tokyo has a const new. So that is the way it works. Otherwise, it's very similar. And then we have the get or init, same thing. And now is a closure with an async block. The cool thing now is we can have async over there. So let's close the module to make some room. We're going to have our debug print, and now we're going to have our devdb init devdb and await. And again, here we're going to break the rule. We're going to make an unwrap, because if it breaks early, it's completely fine. Then obviously the get or init is await. That was the whole point of the Tokyo one cell. So now that we have that, we can go back to our main, and inside our main, after our tracing, so like this, we can trace it. We're going to have a for dev only, and we're going to have our underscore dev utils init. And here we are not putting the question mark at the end because it would just fail if the thing cannot get initialized. And now if you go to the README, we have a starting the DB section. And if you have Docker, we have the password of the root Postgres user as a welcome. And so you can take that and on a terminal, and usually I have a side terminal that I leave running for a while, we can run it. That will run our database. And so now, if we do a cargo run or cargo wash run, we are going to see our trace info that initialize our database before the server start, which is pretty good. And so we have these 3 files that have been executed. Now, another little cool trick that there is in the README, if you go to the second line, you can see that there is a Docker PSQL on PG. You can take it, open another terminal, and paste it, run it, and now you have a PSQL on the Postgres server that we just started before, and you can do /c to connect to the appdb. Then you can list all of the tables that we have. You can select from user, so we have our demo 1, and you can describe a specific table. Here we are describing task. So that is pretty cool. I don't use it often because usually my unit test does the whole thing. But sometimes if I want to double check something, I can start a PSQL on my database. So now, again, it's very cool because every time I change my server and I press save, it will recreate the whole database and everything if I have the cargo watch. And if I don't want to recreate every time I press save, I don't start cargo watch. I just code, and then when I do the cargo run, everything is fresh. Okay, so that will conclude our chapter 4. That was a little bit more code. Now we have a very good foundation to have a very iterative process, and we have completely embedded the database into our development workflow. Okay, so now let's start our chapter 5, which is going to be the first part of our model layer. We're going to do our first task BMC, which stands for Task Backend Model Controller. So first we are going to open the model folder, which is our model module. So in this module, we have our own error, and we are re-exporting the error and the result alias as a module error and result. So we are following our best practice. And then we have the model manager. So in the Rust Axum course, I call that model controller because I merge the two. In this code base, we're going to split. The model manager will have the states, and the model controllers will be the construct that does the access to the different model entities. So the design is as follows. The model layer normalizes all application data types and access. All application code data access must go through the model layer. The model manager holds the internal states and resources needed by the model controllers to access the data. So for example, the model manager will hold the database pool, the S3 client, or the Redis client. So the model controllers like Task BMC, Project BMC, which is for backend model controller, implement CRUD and other data access methods on a given entity, task, project, and so on. Every access starts with a main entity first. And so the BMC, as I've said, is short for backend model controller. Because when we do a UI, we're going to have the mirror of it, which is going to be the front-end model controller. It's going to be much simpler, but it will allow to expose that to the front-end. And then in frameworks like Axum or Tori, the model manager will be used as app state. So there's one model manager, multiple model controllers. And so the model manager are designed to be passed as an argument to all the model controllers functions. And we're going to see how we can protect the visibility of those resources only to the model layer. So now that we have this overview, and we're going to go to our model manager, and our goal will be to add our DB, which will be our database pool connection. So before that, we're going to have to do some work, but that is a goal. And then in the new, this is where we're going to instantiate the database pool connection to set it to the model manager. So to create a new database pool, we're going to create actually a little layer. And this one is going to be very simple for now. It's going to be store. And we're going to create it as a mod.rs because eventually that can grow bigger. So now in the store, since it's a mod.rs, we're going to have our code region modules. We're going to have an error. We'll create an error. It's going to be a very simple one. And I have a little code snippet that creates a whole boilerplate like that. So the design of the errors that I follow is they are based on enum and they derive debug at least. And the reason is because the toString, this is going to sound a little bit weird at the beginning, but actually there's a big reason for that. The toString, which is I'm implementing display, just format the debug format. And the reason of it is because all of the backend server errors are going to be logged as a request log line, and usually that will be a JSON format, a new line JSON. So I do not need to have human-friendly text. So I'm going to make sure that the enum name and properties, if there is, are going to be very self-described, such as I don't have to reformat the message because anyway, the serialization of these errors will be in JSON. So that is why I'm following that for backend services. Now for command line, I like to use this error because it's very convenient to do formatting. But for Tori or Axum web backend services, I usually go with this model. And so then what I do is that my error implements serialize from CRD. And this is again, is because I am in the backend, and it's not because I'm sending these errors to the client, because you do not want to send them to the client, but it's because I want to log them in a new line JSON format, because it's very flexible, and then I can push them into a CloudWatch or another log services. And obviously at the end, we don't forget to implement the error trait for our error, such as we can use a question mark nicely. So now that we have that, we're going to add one error on this one. It's going to be very simple because we're going to use mostly SQLX and then later SQLB. So the store layer in this first episode is going to be very light. And the first error will be fail to create pool. And in this case, I decided to have the string, which is a toString from SQLX. I could also have the whole SQLX object over there. That would be completely fine as well. And then to follow my pattern, I will export the result type alias on this error. So like that, when I go back to the store mod.rs, I can re-export this error and this result for this module. Now on this one, we're going to use our config crate, because that is the whole point, because we're going to have our DB URL in the config, and then we're going to use SQLX, the pool options, the pool, and the Postgres. So first, we're going to define our type alias, DB, pool, Postgres. So now, in the config, we do not have yet our DB URL. So we're going to bring our cargo.ml, and we're going to organize our code as if it were on Kubernetes. So we're going to have a section for secrets, which in Kubernetes will go to a secret config file. And this is an important point. The keys and the passwords that we have here are just welcome type of passwords. They are not passwords that need to be encrypted. We don't have to have all of this complexity because in a deployment, that will be managed by the container, Kubernetes or KMS or whatever on Amazon. But in our case, here in a local development, all can be welcome. So we don't need to encrypt or have fancy scheme here. We can just put our service DB URL like this one, and that will be our app user with our password. And then the only reason why I have dev only PW rather than just welcome is because I don't want both to use the same password, such as I make sure that my dev util codes kind of make sense. That's the reasoning behind. Now that we have that, we can bring our config, and we're going to have a DB URL. And you guessed it, in the load from env, we're going to add DB, get env, service DB URL. Everything is becoming very simple now. And we still have our prefix before, such as we know what comes from us. But sometime in a Kubernetes or in a Docker scenario, you will have other environment variables that might not have this prefix that you still want to have. So you cannot assume that all of your environment variables will have such a prefix. Okay, so now we can go back to our mod.rs, can create our new DB pool that will return a result of DB, and that will be our max connections and our connect. And we can use our DB URL. Now for the max connections, we could have put that in an environment variable. And actually a good strategy will be to put that in the config, even if it's not in the environment variable. So that is a good strategy as well that I like to have. And this will be a good improvement for later. Then obviously that is an await. And then we're going to map the error into our fail to create pool error. And in this case, we're going to do a toString because we need to serialize. But it's actually, we're going to see later that SQLX implement display, and there's a macro that we can use as well. So, but this one, we're doing it manually and it works fine. So now we can go back to our model mod.rs and we can uncomment this one, import the DB from our store DB. And then in the new, we're going to do let DB new DB pool, type will match, await question mark. And now we can do our model manager and we put the DB. We're going to press save. And here the question mark is going to have an error because the new DB pool is a store error and the result is from the model layer. And so to resolve that, what we're going to do is we bring our model error and we're going to implement the variant and the from for the error. So the way that I like to do it is I have a little section like that say all of the modules that I want to wrap, and I put a store and I do a store. I import it and I do error. So like this, I see clearly what type of module I'm using in this error. Then what we need to make sure that the Rust compiler can go from the DB error to the model error is to implement our froms. So I put that in the code region where I'm going to put all my froms. And I have a little code snippets where I put the store and the variant is store. And that's it. So there is some macros and annotations that you can add that will do that for you. But in my case, because I have these little snippets, the overhead is relatively low, and I like it because I have the full control. But again, this is more kind of a personal preference. The important point here is to make sure that you have the right error structure, that the right module has the errors that they need to have, and that they cascade back up correctly. Okay, so now that we have that, we have a little question mark that is resolved over there. So that basically is our constructor that returns the model manager. So now what we want is to expose the DB, the database pool, only to the model layer, and we want to have the new accessible to other modules such as the main.rs. So the way we're going to do that is we're going to do a pub in crate model, which is going to be a function DB, which is going to return a reference of DB. And so this in crate model restrict only to the modules that are below the model. And then the function new is accessible to all of the code base that have access to model manager. That is a way that we're doing it. It's not like a developer cannot make a mistake, obviously, but at least here we are putting the right constraint in our code, such as it's very intent-driven. Only the model layer needs to access to the store. So that is a way to accomplish that. So in short, that returns the SQL XDB pool reference only for the model layer. So if we go to main now, we have our model manager new, and that still compiles. But if we were going to do a db equal model manager db, that will fail. And if we mouse over, we get db is private. That is pretty neat. We're going to remove that. And now we're ready to create our task model controller. So we're going to create our pub mod task, and that will be a single file. That is enough for now. And usually this model controller are more on the leaf side, so they don't need their mod.rs. Having just a file is enough. They will use the model errors. But obviously, if you get more complex, you can have a next level of hierarchy. So we're going to use the model manager, we'll use the model result, and then we're going to use the CRD serialize and deserialize. And it's a from row that will allow us to read data from the database with SQLX and to translate it into a struct. So that is a convenient way to get a struct from a PG rows. And eventually we're going to have more dependencies, but at least that is the beginning. And then we're going to have a code region for our task types. So typically I like to have my types at the top and in their own code region. Often you write them at the beginning and then they evolve less than the behaviors. So that is a way that I split the code. So the first type is going to be task, and that is what is going to be sent back from the model get and list and so on. So it's going to be our pub ID I64 and a pub title string. It's going to implement debug, clone, and then from row, because that will come from a SQL query. And then finally, we need to implement also serialize, because when we're going to do the APIs, we will serialize that into JSON. And then we're going to create another type, which is going to be our task for create. And this type is when we have the APIs that want to create a task. So here is very important. The concept of this design here is that struct are views on your database tables. They are not the exhaustive representation. Sometimes you might have things in the tables that are not the business of an API. And oftentimes you want struct that are only a subset of what you have in the database. So for example, for task for create, you don't want to have people being able to reset the ID of a task. Or you do not want an API to be able to reset the creator ID or the modified time or the creation time of an entity. So that's why you are splitting these things into what gets read and what gets pushed. So in this case for create, we are deciding, just in this example, that you must have a title. And so we're just going to implement deserialize because that is going to be something that is going to come in. And now similarly, we're going to have a task for update. And that is when we are updating an entity. And right now it's going to be a little bit silly, but it's just going to be the title option of string. So on this one is also need to implement the deserialize. If we look a little bit at our three types, we have the task, and that is what gets sent back from the API, from the model layer. And then we have the task for create and task for update. That is things that are sent to the model layer to update the data structure. So because of that, only task needs to implement serialize, and task for create and task for update implement deserialize. Okay, so now that we have that, we can start implementing our task backend model controller. And the design pattern is relatively simple. It's going to be a struct task BMC, and it's going to have no property for now. And then we're just going to implement task BMC, and we're going to implement our CRUD. But we're starting with CRUD, but eventually you can have any kind of method. So it can be very specific to the entity. So the goal here is to have the entity BMC being specific to what they need to be. And then we're going to see how we can share implementation between BMCs. So the create is going to be relatively simple. It's going to return a result of I64. So by design, what we want is that the create is very granular. It doesn't have to return task back. So we're going to make it very efficient. And it's just going to return the ID of what has created. But it's going to take the CTX, which is part of our create CTX. And that is the user information of who is requesting this action. And so the web layer is creating it in the case of a web application. But the point here is that the CTX is decoupled from the framework, from Axum or Tori or whatever. So this way, once it's in the model layer, it doesn't have to know how the request was made. It knows that it can always expect a CTX, which will have context information needed to make sure that the action can be performed. And the ultimate goal of the design, which is going to be in future episodes, is that you put the security layer at the model layer, not at the web layer. This way you can reuse the model in different type of services for job services or web services or whatever. And then the web layer is just about authentication, creating the CTX, but then privileges and everything is at the model layer. So that really simplifies a lot of design down the road. And so this is why we're putting that early on into the system. And then we're going to have our great model manager, which will shorten by MM. And then we're going to have our task C, which is our task for create. Now the CTX and the model manager, those are going to be in all of the BMC functions. And then you have the function specific, in a way, arguments, which is in this case, the task for create. So then in the create, it's going to be relatively simple. We're going to get our DB. And we can do that because we are within the model layer. That will return our DB pool. And then we're going to have our let result, and we're going to call SQLX. And we're going to do a query as, and so that is the way it works. And we do a I64 tuple, and we're going to give our SQL here. So insert into task, title, and the values, which we parameterized. And we're saying returning ID. So another best practice that I always have, I never do raw SQL. It's always prepared statements. So at least that is a nice protection that you get almost for free from prepared statements. So our returning ID mapped to the I64 that we have over there. So that is the way that SQLX works. You have another generic here that you can let Rust infer. So that's why we're putting the underscore. So now that we have that, we can do a bind task underscore C, the title, and then you are going to do a fetch one DB. And at this point, Rust has enough information to infer that we're using Postgres and so on. So everything will be compiling nicely. And then because it's a future, obviously, we are going to do a wait and a question mark. And here we guessed it. In our model error, we don't have the SQLX. So we're going to add that right now. We're going to add a section. We're calling it externals, SQLX error. And now the trick is we do not have serialize for SQLX error. So we could use the technique that we use, the toString, and have a string over there. But there's a pretty neat one. So we can use setIWith with our setIas annotation and display from str. And setIWith is really awesome, so I really strongly recommend it. So now we can do a setIas annotation, which has to be before the serialize. And then what you do is you add an annotation at the SQLX, which is a setIas, and we do a as display from str. And then you pass the error. So SQLX error implement display and from str. And so that allows then the setIas to be able to do the right thing here. So now that we have that, we can go back to normal, and we're just going to implement our froms, which is going to be from SQLX error to SQLX. And then that's it. We're done. Now that will solve this error. And so now the cool thing is anything that comes from SQLX is going to be managed by our model layer. And now one of the things we can do is our result over there, RES, is actually a tuple of I64. So what we could do is destructure it and just having the tuple that will do ID like that. ID is just I64, which is what we wanted. And so we can just do OK ID. And that's it. We've done our create. So now let's go and create some unit tests. So it's always good to start early with a unit test, and you don't have to stress too much about having high coverage. It's more about doing some is much better than doing none. So at the beginning, anything that helps, you just do a unit test for it, even if it's not perfect. And then after you clean them up over time. If you do that early, it's going to speed up your development because it's actually a good cues on things that works and doesn't work. And it will also make your code much stronger. And when it's time to add more unit tests because your code is more mature, it's going to be much simpler. So the same way here, I have a code snippet that create this snippet. I'm using allow unused, but that actually you can remove it. It doesn't really useful in this case because we already have it at the module. I always use super of stars, and then I like to use anyhow, such as I don't stress too much about errors. So now I have another snippet here to add a Tokyo test, and we're going to test, create, OK. So the convention that I like to have is I always prefix with test underscore. That is optional, but I usually have the function that I'm creating, and then I add the suffix OK. And then if I have different tests on the same function, I'm going to say OK simple, for example, and OK double create, for example, to make sure that I can narrow to only one when I want. And then for the error, when the test needs to check if something failed, the convention that I follow is I put a error underscore something, or I just put a error. And right now, because we have only one test create, I'm going to do a test create underscore OK. Now that we have that, we're going to do the setup and fixtures. And for that, we're going to want to use our dev util, and it will be nice to be able to use something that will return a model manager. And right now, the init dev doesn't do that. So if we bring our init dev, we see that it doesn't return anything, which is what we want because we are calling it from main.rs, and we don't want to create an extra model manager. So what we're going to do is create another function, which is going to initialize test environment. So we're going to have an async init test, and it's going to return model manager. And now on this one, we're going to follow the same pattern here. We're going to have init, which in this case could be called instance, and then our get or init that is going to call init dev, and then call our model manager new. And here again, I'm breaking the rule where I do an unwrap because this is just for unit test. So if it crash, it's better that it crash early than too late. So it's completely fine. I don't have to over-design it. But that returns a reference of model manager from the init. But what we want is a model manager. So what we're going to do is am clone. And that is completely fine because a model manager is built to be clonable, such as you can clone it and everything will be below arc. So a clone is acceptable. Now that we have that, we can go back and we can have our dev utils, we import it, and we're going to do init test await. And now we have our MM. And again, it doesn't fail because it will crash, which is fine. So we don't need the question mark. And here we're going to do the CTX, and we're going to have a root CTX. Okay, so what is the root CTX? So if we go into our CTX, right now it's very simple. Just have the user ID, and we have the constructor, which is actually constructors, and we have the root CTX, which is going to return a CTX with a user ID of 0. So that is going to be our root CTX. So rather to have another path for this code, what we do is we have the CTX having the concept of root that the system will use to make the calls that the system has to call. And then we have the new that will take the user ID. So that will be our auth, will create the CTX with new. And then in this case, we are making sure that the ID cannot be 0. With this design, we are intent driven. We know that when we're asking root CTX because we don't have a user, and then when we have a user, we know we can do new, but we cannot get the root CTX with a new. So now that we have that, we have our root CTX so we can make our call. We are going to have our fixture title. Now, one best practice that I follow is I prefix all of my fixtures with fx underscore. So this way we always see very quickly what is the fixtures or what is the value that we're getting back. And then the next practice that I follow is like to have the test create OK matching the function name. So that way it makes the things a little bit more unique. And I could actually add task as well to make sure that it doesn't conflict with other create unit test. So now we can do our exec. For our exec, we are going to create our task C with the fixture title we had. There will be an argument here to say that the task underscore C is more a fixture than a value, but for now it's going to work fine. And then we're going to call our task create with our CTX and model manager and our task C. That will return the ID. And then for the check, we're going to use SQLX and we're going to do a select on title from task. We have the ID and we're going to bind it to ID, which is what we get there. And then we're going to do a fetch 1 and we're going to give our DB. we're going to do the await, and then we're going to make sure that the titles that we get from the query match our fixture title. We're going to do some cleanup. So that is a whole debate about who is cleaning what when, but in Rust, this way works pretty well. And so we're going to do a delete from task where the ID is 1, and we're binding. So even when I do unit test, I actually bind, I do prepare statement. I don't construct fix select statement. So we're going to do execute, await, and then in SQLX we have rows affected that return the count of how many rows were affected by this select. So we're going to do another test, which is going to make sure that we deleted only 1. So that might not be necessary, but it's pretty cheap to do anyway. Now we're going to run our test. So we're going to bring our terminal. Make sure to stop the cargo run. This is one thing I've learned from before, is on Windows, when you have the two running, it creates issues. So if you go to the README, you have a unit test section, and we can do a cargo test watch with a test that will allow us to do kind of a live reload testing. Actually, this is not really repo, it's more watch. And so we can do it this way, where we are very specific, or we can take that, and we're going to add a little filter, which is going to be our test create OK. Usually what I'm doing to test only one by one, and I do the -- no capture to make sure that I have the println. And I'm going to show why later. And then when I do that, we have our test success. So that is pretty cool. Now, one of the reasons why I have the -- no capture is because typically what I do is I do my debug print with my little characters, and then I can print title, for example. And that will run, and then when it's okay, then I do the assert. So often the assert is commented out, or I don't even have it. And then when I'm happy with the data, then I do the assert. That is a little bit my workflow. So my goal all the time is to try to have a workflow where my unit test is part of being lazy to write code faster. So there's one more thing that we need to do, and this is important to do it early, is this test create is testing a database that is getting reset and everything. But tests in cargo test are run in parallel. So it's very hard to synchronize them because you are not even sure if they are going to be in the same process and everything. It gets very tricky. And so one thing that I like to do for all of these tests that use external resources is to use a little library that we're going to add into our cargo to ML dev dependencies, which is serial test. So this one is pretty cool and very simple. You go to your test function and you just add this annotation. Then you make sure to import serial test serial. And that will make sure that everything that is annotated with this annotation will get executed serially. So now all our database tests can use that annotation to make sure that it doesn't work on each other. So that will obviously slow down unit testing, but they will make it much simpler. Now that we have that, and we're going to implement our get. And the same signature again, we're going to have our CTX and our model manager, but this time the argument will be the ID. So we'll take an ID and it will return a result of task. So for that, very simple, we're going to have our DB, and then we're going to do our SQLX select star from task where ID equal $1. And we're going to change that later to make it much more structured. Right now that works very well. And we're going to do a bind ID for this $1, obviously. And then we do a fetch optional, and that will return an option of task. So the good news is we can do an await question mark, which will fail if there is a select error or a database error. But then because we have our fetch optional, that will return the option of task. So now we can transform it into an error of our application, of our model layer, which is going to be error entity not found. And we give the entity name. So by convention, we're going to say that the entity name is a table name, and then the ID. So that obviously is little implementation details of how you want to reference your entities, but the pattern here is very simple and very powerful. So again, the first question mark is going to fail if there's a problem with the select statement of the database. And then the second one is we're taking the option none, and we're making our own exception saying that by convention, a get always needs to return a task. And if it's not, it will return an entity not found. And then we can return OK task. The error, we haven't even imported it. So we're going to use a model error. And then the model error doesn't have entity not found. So for that, we're going to bring the model error, and on top, we're going to add entity not found with the entity, which is a static string, and it's fine to be static in this case, and the ID. And all of that implements serialize because it's simple types, so the entity not found will get serialized very nicely. Okay, so now that we have that, we're going to implement a new one, and that is going to be our delete for now. And for that, similar, we have our DB, we have our delete from task, where ID equal $1, we bind on the ID, and then we're going to execute await, and then we're going to get the row affected. So again, the same concept as before. When you delete something, the convention here that we're going to have in our API is that it must be there, otherwise it will return an error. We're going to do a if count equals 0. We're going to return the same error that we had on the get because the entity was not found. And then we can return our OK void. So now that we have the get and delete, we can go to our test create OK. And then when we do the check and the clean, we can actually simplify the code quite a bit. We don't need to have the select anymore. Now, if you really want to be dogmatic with unit test, you shouldn't be using other functions and some functions. But in all practical matter, I think in this use case, I think it's acceptable and definitely much simpler to use the model function to do the check and the clean. So what we're going to do now is we're just going to do let task, and we're going to do a task BMC, and we're just going to do a get with the ID. And now we're just going to do an assert on task title. And then that's it, we're done. And then we're going to do the same thing for the delete. It's going to be even simpler. Task BMC, delete, CTX, model manager, and then the ID and the await. And if we bring our cargo watch test, press save, and then boom, everything works fine. Now we're going to create another unit test to test the get not found. So that's going to be underscore error, which is going to follow our naming convention over there. And we're going to add the suffix not found. And now for our setup fixtures, we're going to init the test, the context. We're going to have the fixture ID 100. And we know it doesn't exist because we start at 1000. Then we're going to do our execute. And that will do a get. And in this case, we don't want to have the question mark because we're going to test our result, which is going to be a result of task or error. So for the check, we're going to use assert, and then we're going to use another macro, which is matches. And matches works by comparing the result that we get from there to that. And so we have our entity and our ID. And by the way, those guys cannot really be variable, so you have to have the literals there. And now we can do our OK. So if we do our cargo test, and we're going to go back, and then we're going to test our test get error, and that will be the not found. Very simple. And now if we were going to check the wrong entity name, and we do a save, then our test will fail, which is what we wanted. So let's make it work. And we have this unit test done. So again, we don't have to go crazy and do everything, but it's always good to do few. So we're going to do the delete as well. So the fixtures, we're going to exec, and then do the check, which is exactly the same one. And then that's it. Now, if we go back on top, we're going to implement our list. And for now, in this episode, the list won't have any filters or order by or limit or offset. We're going to do that in future episodes. So we're laying down the ground right now, such as we can scale very nicely. But for now, the list is very trivial. We do the DB, we do a select, we do an order by, we do a select star for now. We're going to fix that later. And then we do a fetch all. That will return a vector of task. And then we just do OK task. Now, one thing that I like to follow, the CRUD naming convention. So create, request, which is a get and a list, update, which we don't have yet, and the delete. That is the way that I like to order things. So now we're going to go down and we're going to create our test at the right place for list. So now the thing in the list here is the fixtures will have to create many tasks, and that could be kind of cumbersome all the time. So what we're going to do is we're going to go to our dev utils, and next to the unit test, we're going to create a seed task. So that is a utility that we're going to use in our unit test. And so it's going to return, and here we're going to be explicit, model result of vector of task, and it's going to take the CTX, the model manager, and the title can just be an array of string. So we're going to do the import. And so in this case, our dev utils will have a dependency with the model layer, which is okay. The other way around is not, but this way is okay. And now we're going to have our mute task. And then for every titles, we'll create the task with the title. And then we get the task with the ID that we got from our crate. And then we push it to the vector. And now we're going to return. So very simple. Now you need to make sure to import everything. And now that we have that, our unit test is going to be much simpler. We init our test, we have our CTX. The fx titles is going to be an array of static strings, which is fine. We're following our convention of duplicating the test names over there. And then we're going to call our dev utils seed task and give the array of titles. Then we're going to exec, and that means that now the task will get this list over there, at least. So today, because we don't have this filter kind of business, this unit test is not very strong. It's kind of a little bit clunky, because if other tests create other tasks, you will see them as well. Yeah, so you don't know if you are the only one hitting the database at any given time. So the way that we're going to do it in this case is you want to make the name as unique as possible for this task. And the check, we're going to filter through all of the tasks, and we're going to make sure that it starts with our prefix. Eventually, our list will have a filter API, so we'll be able to be much more precise into what we ask our backend model controller. And then we collect to get the vector of task. And now that we have that, we're making sure that we have only 2 tasks, and then we're going to do the clean. So now we have the task over there, so we can iter, and then we just delete like that. So this one is not a very robust unit test because we are doing this like prefix stuff, but it will work fine for now. And again, some is better than none, because when this one breaks, then you just fix it and make it better. It's always a good way to start. And the important point is to know what needs to be improved, is not to always hit for perfection. Now, one little addition that we can do on this one, since we don't have a filter, is to actually make the name a little bit more unique. So if we go back up, we could make it -task, such as if we have another test list for another entity, at least it won't work on each other. So that is a very cheap tuning that you can do at the beginning. And then eventually, once you have the filter and everything, you can get much more precise. And now we can bring our terminal, and we're going to stop it, and we're going to test the list. We could do a test list like that. Or actually, what we can do is a test model, and we go by package now. So we're going to test all of the task tests. And now if you press enter, then you get everything run like that. That is, again, very nice, the way you can filter things. Okay, so that was quite a bit, but we already have a very good start with some very good unit testing already. Now again, usually I use that not only after I code my function, but often I use that during the implementation, where I do something like that, where I don't have the assert and I do just a println and a task debug like that. And then I can see that on my terminal, I fix the code, I make it exactly the way I want it, and then I do the assert. That is the thing that I was saying before. Okay, so that will conclude this first part of the model layer. Eventually, we're going to do the update function, and that will be part of the next chapter. So now we're going to do the chapter 6, which is going to be our second part of the model layer, and that will be the shared implementation. So when we have our task BMC, what we can see is all of this code that we're doing for the entity task. We're going to have to do it for other entities as well. So everything here in the insert, in the title, and so on, we're going to have to repeat it for other types. And obviously that is going to be true for all of the other functions. The basic CRUD will generally have a lot of common behaviors across entities. So what we want is to be able to share implementation between all of those BMCs. So typically in most languages, you will do that with inheritance. But in Rust, for better or worse, we do not have inheritance. I think is for the better, but that can be arguable. Regardless, we do not have inheritance. And what we don't want is to try to mimic inheritance in Rust, because that will be a misfit. But in Rust, we have many constructs that can be extremely useful to have shared implementation. And we have 3 big categories. The first one is the traits. You can also have blanket and default implementation, or just the traits alone. And then we have the generics that bring monomorphization and dynamic dispatch. And finally, we have the macros, the declarative macros, which is the macro rules, and the procedural macros. Now, to share the implementation of the BMCs, we're going to use a trait. We're not going to actually use blanket or default implementation, just the traits with the generics. And that will give us monomorphization. And then we'll be using the macros later in the chapter 9, where we will use declarative macros for the RPCs routing. Okay, so with that in mind, let's go back to the code. So we're going to open our model mod.rs, and we're going to create a submodule, which is going to be base. And we can just create a single file. And it's important to note that all of those are kind of private to the model layer, and only the task is going to be public. And then obviously we're re-exporting the model error and result from our error module. So now we can drill down into our base. We're going to use the CTX, the model manager, and the model error and result. We'll be using also the from row in this case. And now we're going to implement our trait, and we're going to call it db-bmc, which is for the backend model controllers that are DB related in a way. And the only properties that it has, and this is a little trick here, is that we can use consts. So that will allow us to define a const property for the db-bmc trait, and it's going to be static str, and that will be our table name. So now that we have that, we can create our async function, which is going to be just a get. And note that in our case, we're not going to create struct and trying to mimic inheritance. Function is completely fine as a shared implementation. In fact, we're going to see that we can use generics to pass types information into functions. So here's how it works. We're going to add a generic to our get, and we're going to call it MC for model controller, and that will map to the concrete type that will implement our db-bmc. And then we're going to have E, which is going to be for the entity that it returns. And now we can have our functions that take our CTX. We do underscore because at this point we're not using it. And then our model manager we're going to use. And then it's going to have the same signature as the specific get, which is going to be the ID, I64. Now it's going to return the result of E. Now, why we have this little yellow line is because we are not using MC yet. We're going to use it and define later. Now we're going to define our bound, our trait bounds with where, and we're going to say that MC needs to implement db-bmc. So we will have the table const. And then for E, we're going to say that is a from row because we're going to use SQLX. So we want to make sure that we can get the data back as a normal struct that implement the from row. Now the from row has a little trick, is that if you press save, you are going to have this error. You are going to see that it takes a generic. And actually it takes 2 things, a generic and a lifetime. So it's from row, the R lifetime, and then the R generic, the row. So one thing that we might be tempted to do will be to add lifetime over there, and then we do a lifetime R here, and then we're going to do the PG row. So that is the type we need to have. I'm going to import it. And that will actually compile. So we will think that we will be happy. But it doesn't really make sense because the lifetime R is not mapping to really anything useful over there. So the compiler won't have its work to be able to trace back who owns the data. So the right way of doing it, and long story short, is don't put it there. And we're going to use a higher trait bound, which is a special notation with for and the lifetime R. And now that we have that, we have the E, which is a for from row, which fits well into our get and our E, and now it's kind of independent and has its own lifetime in a way. Now there's one more thing we need to do in our E. Since E is part of an async function, we need to add the auto trait unpin and send. So that is important, such as it can work well with the async. That and the higher thread bound could be the subject of another video, but this is a way to define our E for our application. And now that we have that, we can go to our task BMC get. We take all of that and we're going to paste it there. Now task is obviously not task anymore, but E. So we need also to change it in the select statement and in our error entity not found. So for that, we're going to create our SQL with a format. We're going to take that, put it there, and then we're going to replace task with our MC : table. So now we can remove the SQL and just put it there. Now our task is not task anymore, it's E. We're going to rename the variable as well entity to make sure that everything is consistent. And now the last one is our error, and you guessed it, it's going to be MC table. And then that's it. We have our function. It's very generic, can be used in many places for many entities. We're going to see later how we can even make it better for the select star, but this is already a very good start. Now, if we go to our task BMC, what we need to do is implement db BMC from our base for task BMC. And now we're going to put our const table static str task. Now we can go to our get, take that function and replace it by base : get. And the way we are going to pass task BMC self is with the turbofish notation, and we're going to put self and then task. So that is a way that we're defining those two generic that this function needs to take. Then we're going to pass our CTX, our model manager, and our ID. And that is async, await. Make sure to import the base. We can remove the underscore on this one, because this one is actually using it because it's passing it down. And now the task that we have there, which map to that result task, the compiler can infer it. So what we can do is just put an underscore. So that's why sometimes if you look at code, you see the underscores, because we let the compiler infer things when it can. And now if we bring our cargo wash test, press save, everything was fine. So that's why it's good to have the test, because at least we know that we didn't break anything. So this pattern is going to work very well for the get, because our E that we have for our get is going to implement from row. So that's great. So for get and list, that is going to work perfectly fine. Now, what about update, for example? If we had update over there and we're giving our ID still, and then we have our data, but what would be the type of data? Because the from row is not a two rows. So if we wanted to have in the generic side, we need to be able to pass something that can become a two row. And that is where we're going to use a little library that I've created, which is a SQLB, which is a SQL builder on top of SQLX. So the goal of SQLB is not to replace SQLX. You still use SQLX in many places, but sometimes it's a very convenient way to be able to build your SQL with a higher level kind of a builder pattern kind of things. SQLX has a lower builder pattern as well that you can use, but this one is going to help us a lot to solve this problem. So now that we have that, what we can do is the following. So the bare bone, we can even change the get. So for the get, we can change our SQLX query as for SQLB, and we are just going to do a select. So that will return a select SQL builder from SQLB. And once you have that, you specify the table. So in this case, it's going to be our MC table. And after, we're going to do a and where ID equal, and we're going to do the ID like that. So this is kind of a builder where you can add multiple and where and so on. So for complex requests, use SQLX. But for simple one, that can provide a very good one, and eventually will support more complex cases. And underneath is just use SQLX. So that follows a builder pattern. So we have a select builder, and then that will return it over there. And then we have the same API as SQLX, which is fetch optional, and we give our SQLX database pool. And then we do the await, and then we still have the honor. And we're going to see later how this can also help the case of create and update. So now we're going to bring our cargo text terminal, press save, and then everything works. So we didn't break anything. Now there's one more optimization that we can do on the get alone, is the SQL-B select. By default, we do a select star like we had before. But sometime, and moreover in our design, the type is just a subset of your table. So you don't want to do a select star. That will be inefficient, and there is data that you might not want to get back anyway. So what we would like to do is, rather to have the star, we would like to have only the field names that it takes. And that is where SQL-B is also useful. So if we go to our task types, we can add a macro which is fields, and we import it from SQL-B, and that have a couple of functions, couple of methods that are going to be very useful to compose your SQL like that. So this is not about being a big ORM, it's more about being a SQL builder. So in this case, for example, SQL-B doesn't know what types maps to what table, but it's more a way to build your queries and compose them. So now that we have that we have E annotated with fields, the E will implement a trait which is has fields. Now, in Rust, you can do your trait bound like this. You can duplicate it to add it up, or you can also put it there in one line with a plus sign. I like to have it below in this case because the one on top is already complex enough. So I like to split them in this particular case, but that is a personal preference. Now that we have that, we can do our columns, which is part of SQL-B, SQL Builder, and then we're going to have an E, and the E has an associated function on the type, not even on the instance, which is field names. And then voila, what we have is all of these names, ID and title, is like if we had them in the select like that, and it does the double quote and all of the fancy Postgres stuff. And then if you have other properties, like for example, something else, and you don't want it to map it into a database, you can annotate it like this, where it's a field skip. And so in this case, it won't be a field, you will skip it. And if you want to rename it, for example, you have desk, and in the database is description, you will put it name description. Then if you do that, and that will match it up there, like select ID title description. And now if you do that, do not forget, because that in fact is just for the field names and the to row, but from the from rows to be able to have the fetch optional and fetch all work, you still need the SQLX naming convention, this one. Eventually I might have SQL-B understanding the SQLX rename. I don't know if I want to get there, but at this point you can do this annotation and it works very nicely. So in short, the SQLX rename is for the from row and the field name is for the fields. So that is the way it works. So now we can remove our SQL and we are all set on our get. Now we can copy it and we are going to do our list. And that is going to be very trivial. And the reason why it's trivial is because we do not have yet the filter, the order by, the limit, and so on. And that is something that we are going to do later. Now, the result is not going to be E, it's going to be a vect of E. The bounds are going to be exactly the same. So we've done all of the hard work. And now, in our select, rather to do and where, we're not going to put any filter, and it's going to return a vect of E. And that is going to be entities. And we're going to remove the OKR entity not found because it doesn't make sense. And if there's nothing, it will be an empty array. And now rather to do fetch optional, we're going to do a fetch all. So the SQL-B is really matching the SQLX API. And now that we have that, we can actually add one more thing, which is the order by ID. So that will allow us to do a select and be kind of deterministic into the order by. So by default, order by ID, and then you can enhance your APIs to allow the user to order by other things, which is very important, obviously. Now in SQL-B, if you put an exclamation mark, that will be a descending order by, and without exclamation mark is a default, which is the ascending one. So that is a little trick here. So if we close that and we're going to go on top, we're going to create our create. So our create will have the MC model controller generic, which will be DB BMC. It will return a result of I64. So that is the API contract that we have. So we're going to normalize that across everybody. And then it will take the CTX and the model manager. And then it will take a data of E. And this E, the only thing it has to implement right now is has fields. And in SQLB has fields, it will allow you to extract the fields name and value, such as we can inject it without knowing what is a concrete class. So that is a little trick that the SQLB is doing. So now that we have that, we can get our DB, and we are going to call the let fields data not known. And that will return a vector of field. And we're going to see later what the not known means. So now we're going to do our SQL insert, and we will be returning the ID. Then we have our table, and then our fields. So the strategy that we're going to take right now is that our fields, which is going to be what we put in our data, is going to be the not known fields, which means that any value which is either not an option or an option that is not known will be set, and otherwise, if it's known, it will be ignored. Now, this is just a strategy that we're taking in this particular case, but if you want, you can have all. In this case, you assume that your E will have all of its data set to the right value, and it might set null to the database. So that is, you have either strategy, and there's pro and cons to both. For now, we're going to go with the not known fields, which means that if we wanted to set null to the database, we'll have to have another way of doing it. Perhaps another APIs, or perhaps a flag or something like that. And now what we're going to do is we're going to do a returning ID, and that takes an array of strings. So that is what will allow us to get the ID over there, which is what we want to return. And now we do a fetch one to be able to fetch the ID, and we do our wait. And then that's it. We do our OK ID, and we're all set. And so that, our insert, is creating an insert builder, and then we have our builder pattern over there. So now that we have that, we can do our update. And I'm keeping the CRUD order over there, so this is why I move a little bit up and down. So now, for the update, we're going to have the same thing here, the model controller and the E. We're going to return void, so our BMC is going to be relatively granular, and then our web API, the way we are going to design it, is going to be a little bit more convenient. But obviously, you can have the web APIs that map one-to-one to your BMC API. We have our data E, but our convention is to have our ID. So we don't have the ID part of E in our case. The ID is outside because it's not something you are modifying. It's something that you are using as a reference. And then data is the data that you want to modify, whatever you are calling to. So now that we have that, we're going to press save. It's going to do some reformatting. We have all our arguments over there. And now we can do an OK void. And rather to do an insert, we're going to do an update. And that will be our update SQL builder. And now we don't need the returning ID. So we're going to remove the fetch one and just do an exec. And that will return count. And obviously, we do not want to forget the and where ID equal ID. Now that we have that, we're just going to check that the count is not 0. And if it is, we're going to return our entity not found. That is going to be part of the contract that we want. Obviously, that is up to you when you develop your APIs. And then if it's OK, we're going to move the OK over there. And then that's it. That is as simple as that. And now we're just going to do the delete, which is probably going to be the simplest one. So the only thing it will take is the ID. Then we have the DB, our delete, the table, the and where, the exec. And then we're also going to check that count is not 0. And then that's it. And this, if we go back up, that will conclude our shared implementation for the base, at least the beginning of it. We have our DB BMC with the table constant, and then our CRUD shared implementation that we can use in our specific backend model controllers. So now we can go back to task. And what we're going to do is we don't forget to add fields to the task for create and task for update. So the from rules is to read, and the fields is to write in a way, except that we are also using fields to optimize the fields names that we want to get from the database as well. So now that we have that, we can go back for our create. We're going to replace that by the create function, and it's going to have the same signature. So now that we have that, the get, we already have done it. And then the list, we're going to do the same thing. Base, our self underscore, and then the same signature. And that will return our result of vector task. And then we can add the update, and it's going to be trivial now. And it's going to take the CTX, the model manager, the ID, and the task for update. And then we're going to do the update self underscore ID and task U. And we're going to do the same thing for delete. And that's it. So the nice thing about this design is that all of the application code is going to call the specialized BMC, task BMC, project BMC, or whatever entities you have. And then you can share implementation behind the scene. And those implementations that you share doesn't have to be struct or within a trait or all these kind of things. So this is where we have to unwind a little bit from the Java days. Not everything has to be in a class or in a struct or whatever, or in a trait. And now if we bring our cargo wash test, press save, rebuilding, everything is okay. Okay, so now we can build some unit tests, and we're going to build our update. And the reason why it's important to build that is as you refactor, you want to make sure that the basic doesn't break. The strategy is always to have a good 20% or even a good 10% where things tend to break. And you always want to have that as early as possible. And then after you can climb your way up. So we're going to have our dev utils init test, our CTX, our fixture title. We're going to do the task 01 on this one. And then our new title, we're just going to suffix it. We're going to seed our task, such as we don't have to create it by hand. And we're doing the remove 0 to pop it out, basically. So we have our task over there. That is a little bit ugly, but that works fine. And now that we had that, we're going to do the exec. And that will be an update on CTX, model manager, our fixture task ID. And then we're going to create our task for update, which is just going to have our new title. And then we do the await. And then on the check, we get it with our fixture task ID. And then we're going to do an assert on the title and on the fixture title new. So now if we bring our terminal with our cargo wash test, we already press save, so we can see that we have it there. And then if we press save again, we're going to have it there. And by the way, the order, even if we have it serial, is not guaranteed. So that's why we have it in different places. So now if we go back up, and we're going to review what we have done. So what we have done in the last two chapters is we have created our model task module, which is responsible of all of the types and behaviors that relates to a task entity. We have our task type task for read, then task for create, and task for update. Then we have our struct task BMC that implements DB BMC, such as it can use a shared implementation of our base BMCs, and then we have our implementation for the task BMCs. And now the implementation today are just a one-to-one map with the base BMCs, but a task BMC could have specific implementation, for example, lock task that will make sense only in the task concept, and that will go there as well. And in fact, later in the user BMC, we're going to see that we're going to have behavior that only belong to the user BMC struct. We also have created our test, such as we have the basic test for our task. And then in this chapter, what we have created is our base BMC with our trait that has for now one property, a const, which is a table name, and then the shared implementation for the basic CRUD functions. And in this case, just a function and using generic was completely enough. We didn't have to put them into a struct and other kind of traits. And that gives us a simple but scalable model to scale our BMCs. So now let's do chapter 7, which is going to be password encryption and user login. So let's look at our request flow. So our API login is going to be over HTTPS. So during development is going to be HTTP, but in production is going to be over HTTPS. The payload is going to be of format username and the password in clear. When you get into our handler, the handler will use user BMC and will do a first by username from the database. That will return a user for login struct, which will have the username, the password, And we're going to have this multi-scheme here. And then the second part will be encrypted, obviously, one-way encryption. And then we're also going to have the PW salt by user, as well as a token salt by user. So we're going to have a secret at the application level in the application config. And then on top of that, we're going to have a salt per user. So it's going to be relatively secure here. So then the login will do an encrypt and a validate. So in the encrypt, that will generate our PWD that then we can compare to the user PWD that we got from our user for login. And then in the next chapter, we'll do a create token, where we will create a token with this format and we'll put it in the cookie. That will be the next chapter. So let's go to our model, mod.rs, and we're going to add a module user. We're just going to create a single file, that is enough for now. And then if we get into it, we're going to bring our create schema SQL, make sure to add the comma, and now we're going to add our auth properties, which is a password. So that will be a 256, should be enough. And then we have a password salt. We're going to use UUID for that, and we're going to actually have the database creating it for us. So we could create it on the Rust side, but actually it's good to have the database doing it. And we're going to follow the same pattern for the token that we're going to use in next chapter. So now that we have done that, we're going to use the CTX, the base, and the model manager, the model error and the result. And then we'll use the CRD, the SQLB, and the SQLX. And then we don't forget to use the UID. I like to create my types under a code region. And we're going to have our user type. It's going to be the serialize, because that is going to be what we're going to send back. We're going to have the from row and the fields, like we had on task. And it's just going to have ID and username. The very important point is that the user type, since we're going to serialize it, you do not want to have password. We're going to have a user for create, which will have deserialize, and that will have username and the password in clear. So that is what is being sent from the client, or even from some server APIs that will create a new user with a clear password. And that is only a deserialize when it comes. We're not going to have an API to register, so we're not going to really use a deserialize. So it's always good to have that anyway from the start. And we're going to do the user for insert. So in the user for insert, that is when we're inserting a new user, and that is more kind of an implementation detail of the user module. So we don't really need to have it pub, so we can actually remove the pub, and then we're going to have our user for login. That will be a read only. So that is to have the information necessary to validate the login. So it will have the from row, and that will be our ID, our username. And then we have the password and token information, which will be our password, which is an option of string. And that will be encrypted with pound, the schema ID pound. In the next episode, we're going to do the multi-scheme. But if you start by encoding your scheme as part of your password, so then after you are going to be future-proof when you want to change the keys or the algorithm of your password without locking the user out. And then obviously the ... is going to be fully encrypted. And then we're going to have our password salt and our token salt, which is going to be UUID. And SQLX supports the UUID, so all is good. And now we're going to create another struct, which is going to be the user for auth. So we're going to make a distinction between the two. So the user for login is for the login logic, and the user for auth is for the authentication logic. So we're going to have the same derives from row and everything else. And it's going to be ID, username, and then we just need the token info now. So it's going to be our token salt. So in a way, this one is a subset of the user for login. Okay, so now we're going to use a nice pattern here, which is going to be the marker trait. So we're going to have a trait, which is going to be user by. And this trait will have the trait bound of as fields, as well as our from row. Make sure to import the has fields from SQLB. And now that we have that, we're just going to mark our user structs with this trait. So we're going to implement user by for user. We're going to do the same thing for user for login, and same thing for user for auth. So in a way, this trait didn't add any information to these three structs, but it groups them together. So now these three structs share this trait. So that later is going to be very useful. We're going to see how we are going to use that. And we are also adding the trait bound over there, such as we don't have to repeat ourselves later. So now that we have that, we can close our user types. We're going to create our struct user BMC, and then we're going to implement our DB BMC for user BMC. We're going to put our table, map to user. We're going to create our implementation. And the first one is going to be our get. Now the get will return a result of not user. We're going to make it a little bit more generic, but not too generic. So it's not going to be result of user, but it's going to be result of E. And now we have the E, which is user by. So this way, because we have our marker trait over there, that will make sure that only these three types, user, user for login, and user for auth, can be returned. If we were not going to do that, application code could call user BMC to get other types. It will probably get a SQL error, but that would be the wrong intent. So this way, get is still a generic, so it's flexible, but it's kind of limited into the type it can return. So now that we have that, we can just do our base get and even do the underscore. So obviously we can put E, that will be fine too, but underscore will be fine. And now, in the case of user, we do have a specific get in a way, which is going to be a first by username. And it's going to return an option of E, takes the CTX, the model manager, and the username. The API convention I like to follow is when we do a first, we will return an option of E. So none is an acceptable answer of a first request. However, when we do a get, none is not acceptable. It has to be found. And now that we have that, it's going to be relatively easy. So we're not going to be able to reuse the base shared implementation. And in this case, we're going to have something specific to user. We're going to still use SQLB, but you can use obviously SQLX directly or even Diesel or whatever. It doesn't really matter. We're going to do a select table. We're going to add the and where username equal username. And we're going to do a fetch optional, which will return an option of E, which obviously E is of trait user by. And now that we have that, we can replace our to-do with OK user. And so that's it. In fact, we can do our little unit test. So I have a snippet, and then we're going to add our use crate, our serial, and then we're going to add test first OK demo 1. So in this case, I add the suffix underscore demo 1, such as I'm a little bit more specific, and eventually I might have OK something else or whatever. And then that would be a Tokyo test because it's async, serial because it touched the DB. And now I do my setup fixtures, demo 1, and then we're going to do the exec with the first by username. We do the question mark, which will fail if there is a select issue or a database issue, but it will return an option of user. What we want to make sure is that there is a user. So we're going to use context from anyhow with a message. And so we're making sure that now we have user. And now that we have that, we can do a check that the username match our fixture username. And now we can replace our and with OK. We need to import the anyhow context trait. If we bring our terminal and we do a cargo test, that will work completely fine. And then just to make sure that we didn't break anything else, we could do a cargo test of everything and we get our user test. So everything is good. Now the cool thing about that is we could have done a user for login. That will have worked exactly the same. In fact, if you press save, that will work. And we could have done user for auth as well, because these three types implement user by. And Rust will generate all of these functions like underscore user, user for login, or user for auth. So that is what is happening behind the scene, which is monomorphization. So it's going to create more code, but it's very productive to use, and it's a good code design to have. So now that we have that done, we can start doing our login handler. So let's step back first and look at our login flow. So what we have done is that. So we have the first by username, which can return user for login or user for auth. And now what we need to do is the encrypt and the validate. And in the next chapter, we'll do the token. So for that, we're going to our main.rs and we're going to create a module which is crypt. We're going to do a crypt mod because it's going to have some modules, one for password and one for token. And then we're going to get into our crypt module. And for our encryption and our encoding, we're going to use few crates. So first, we're going to use rand for the random numbers to create the keys. We're going to use hashmac and SHA-2 for SHA-512 to encrypt our password, as well as our token, actually. Now you can use any encryption algorithm that you want. This blueprint doesn't really dictate one or the other. This one is a good start to start with. And then finally, we're going to use base64 URL. So the goal here is the opposite of encryption. The goal is to be a relatively efficient way of encoding and decoding bytes into a safe character set. And then we have the UID that we already had from the baseline. So now we're going to create our modules, code region, and we're going to have our error. So that is what we're going to create right now. I'm going to use my snippets to have my code template, and that will be to be coded for later. So I start with that right away, such as it's going to be simpler later. And now, because this error might be cascaded back up into the web layer that will need to be serialized for the request log line, we're going to make it serialize. Okay, so now we have that done. We're going to re-export our error and our result. Then we're going to use hashmac and SHA-2, the SHA-512. I just normalize everything to SHA-512. And then we're going to create our encrypt content struct, and that is going to have two properties, which is going to be the content, which is going to be a clear content, and the salt, which is going to be a string. The reason why both are string is because we want to keep it relatively flexible, such as when we change our encryption scheme, we're not tied to any specific types. So everything is always a kind of a toString anyway, and then you can go to a byte array from a string. And now we're going to do our base encryption. And right now, everybody is going to use this one. But again, eventually you can have different strategies and different encryption for different things. And so what it's going to take is going to take the key, and then it's going to have the encrypt content. Then it will return a result of string, which is going to be our base64 URL. And the encrypt here is always going to encrypt into a B64U, which is B64 URL. And the reason why we encrypt it into B64 URL has nothing to do with security, obviously, because base64 has nothing to do with security. It's just the fact that you have a safe character set that can be shared and stored and passed around in a very versatile way. So that's why we're normalizing everything into this base64 URL. Then the first line will be to destructure our encrypt content into content and salt. Then we're going to create our hashmac SHA-512 with our key that we got there. And then we're going to map it into our error. For that, we're going to bring our crypt error, and we're going to add our first error, which is for key, and that will be a key fail hashmac. And we don't really need to capture Y for now. So typically, if I have a doubt, I don't capture too much information. If I need, then I make sure that I capture it. So the way that you add the content and the salt is this way. We do an update, and we do a content as bytes, and then we do an update and a salt as bytes as well. And then we're going to finalize and B64 URL encode. So we're going to do the hashmac result. We're going to finalize, and then we're going to get the bytes. And then once we have the bytes, we're going to do our base64 URL, and then we're going to encode our result bytes. And now we can return our results. And then that's it. That's the basics. So obviously you can use any encryption scheme you want in this case. So you could use Argon 2 or whatever. Now that we have that, we're going to create our unit test. So we're just going to use super and anyhow, and we're going to use our rand because we want to create a key. So the check is really going to be basic. It's just more to make sure that everything works fine. And in this case, for me, it's more to look at what gets generated. So we're going to do a test, encrypt into B64U, and OK. So we're just going to test the OK. And for that, we're just going to put the test. We don't need to have Tokyo test. It's not async. And our setup will just be our key, 64 bytes for 512 bits. And now we're going to fill the bytes with random. We're going to create our encrypt content, and then we're going to call our function. Now, what we really need to do a full test is to have a fixed key and pre-compute the arrays and check that. But right now, the only thing we're going to do is going to be a little bit kind of a fake one, where we're going to encrypt it again, and then we're going to check that the two match. So it's not really a real test, but it's better than nothing, and we're making sure that the very basic of this function works well. So now we can bring our terminal. We're going to do our cargo test with a no capture. That works fine. And typically what I've done to develop to make sure that things kind of make sense, I just do a println. And I can see that it does make sense, and the character set looks like to be a B64. So again, this is kind of a weak test. We can beef it up later, but at least it's a start and a placeholder. So now what we want to do is to create a key that we can store in our config. So for that, we need to have a little utility. And the cool thing is we're going to copy paste those two lines, and we're going to use the examples infrastructure of Cargo to have our little custom script. And that will be a gen key. That wouldn't work for everything, but for this one, it works perfectly fine. So we're going to the gen key, we're going to use anyhow. This is not really application code, and we're going to use the run call. Then we're going to paste our code to generate the random 64 bytes. We're just going to print it. But again, because we want to have a relatively safe character set, so what we're going to do is we're just going to do a base64 URL and code, and that will return a base64 URL string. And that is what we're going to store as config. We could use base64 as well, that would be completely fine, but I'm normalizing everything with base64 URL. So now that we have that, we can have our terminal, and we're going to do our cargo, run example gen key. We have the array here that we cannot really do anything with it. But then we have our base64 URL encoded string. So now we're going to go to our config.ml, and we're going to add our service pwd key and just paste it. Now it's going to be a little bit confusing in Kubernetes, because in Kubernetes secrets, all the values are base64 encoded as well, but confusion apart, everything will work very nicely. So since we're here, we're going to do the same thing for the token key. So I just ran it to have another one. And we're going to have a duration in second, which is going to be 1800, which is going to be obviously 30 minutes. Now, every time I'm debating, this is not really a secret. Should it go to the config map? But I like to have the thing close together. So that is an internal debate that I always had with myself. Follow the best practice that you think is right. That could go to the config map section. So one thing very important though, is my strong recommendation is every time you store duration in string or primitive types like numbers, always suffix it with a unit. Because the last thing you want is to think that a duration is in millisecond when actually is in second. Because in this case, it will never expire. So that is why always suffix it with a unit, such that there is no confusion into the scale of the duration. So now that we have that, we can go to our config, and we are going to add section for crypt, key for password, which is going to be a vect of U8. So the goal is to have the config relatively well typed, such as it's simpler to use. And also we have the validation early, such as it will fail early if the format doesn't match the type. And then we're going to add the same thing for token keys and duration. And again, even in the property, we're putting the duration unit. And the type will be F64. So now in our config, we need to create those. And ideally, what we would like to have is a getEnv that will parse a B64 URL as an array of U8. And then we would like to have the same function for the token key. And in fact, for the token duration, we would want to have a getEnv parse that will parse the thing into whatever type we want. So one, we give the information that is a base64 as U8 array. And then the other one is just a parse because we know the landing type here, which will be F64. So let's create these functions. So first our getEnv base64 as U8 arrays will take the name and will return the result of the vect of U8. And then we can just do a B64 decode of our getEnv with a name, such as if there is an error of missing, that will take care of it. So obviously our decode has its own error, which we don't really need to pass through. So what we're going to do is going to map the error into an error config wrong format. So that is what we're going to use, and we don't really care to know about the exact cause. is going to be usually relatively obvious. So we're going to add this error to the crate error. So that is the application crate error. So now we can also do our get_env parse, which will take the name, and it will return a result of t, such as we don't have to do get_env parse f64, i32, and so on, but rather to have a t that will implement from str. So that is part of the standard library, and that will allow us to have the parse. Now we can get the value with our get_env, that will give us a string, and now we can just do a val parse t, since t implement from string. And the same thing in this case, we don't really want to pass through the error, so we're going to map our error with our error config wrong format. And in this case, we don't really care the cause. Most of the time it will speak by itself, and eventually we could add another property into our wrong format, which will say the expected type. But so far, we're going to keep it simple like that. So now we need to make sure that we import our form str from the standard library. And now that we have that, if we go back up, everything compares nicely. And then we get all of these properties from our config. And best of all, they have the right type from the get-go. So if they have the wrong format or if they are missing, the application won't even start, which is what you want. And now we can go to our crypt. We're going to go to our mod.rs and we're going to add a pub mod pwd. So we're going to create it as a single file. That's fine. We're going to use the crypt error and result, the config, and the encrypt content that we just created. And now we're going to encrypt with the default scheme. So we're not going to implement the multi-scheme right now, but we're going to encrypt our password in a future-proof way, such as we can implement multi-scheme later. So the nice thing is you could go production with that, but because we will already have the scheme 1, we'll be able to add that later, and everything can be gracefully upgraded. So now we're going to have our encrypt password, which will take the encrypt content and will return a result of string. So now we're going to get the key. And so the encrypt password function will know that the key is a PWD key. That is part of the responsibility of this function. And now the only thing it does is going to say let encrypted. We're going to call our encryption method with our key and our encrypt content. And now that we have that, which is a string, we could do OK encrypted. Now the problem of doing that is that we wouldn't be multi-scheme ready because the encryption would be completely opaque. So we want to make sure that we have a little marker such as we know which kind of encryption scheme we have been using. So for that, we're going to do a format and we're just going to name the first scheme that we have 01 like that. And we're going to put our encrypted after. So that is going to be the encrypted part. So we didn't change anything about the encryption, but what we did is we added a little marker that said that is our first scheme. We don't have to say which scheme it is, but at least now we know with which scheme this password has been encrypted. Such as later, if there's multiple schemes, we can match to all schemes when we validate passwords. Okay, so now that we have that, we're going to create our validate password, and that will validate if an encrypt content matches. So we take the encrypt content, which is what we have over there, and then it will take the encrypted password, and that will return for now a result of void, which means that if it doesn't fail, it means that it succeeds. So first we're going to encrypt the password as if we didn't have the password reference. So we're just calling the same function, and then we're obviously going to compare. If it's equal, it's okay. And if it's not, we're going to return an error, which is password not matching. So let's create that. We're going to bring our crypt error, add a section for our password, and then we're going to add this password not matching. Okay, so now that we have that, we've fixed our error, and now we have the validations that work with our password and our encrypt content. So we're going to take our encrypt PWD, and now we can go to the user, and we're going to add a user-specific method, which is going to be update password. And it's going to return a result of void. And it's going to take the CTX, as always, the model manager, the ID of the user, and then the password in clear. And then in our function, we're going to get our DB, and now we're going to get our user for login by ID. So this method assumes that we already have the ID of the user and we just set the password. And now we're going to have the password, which is going to be our encrypt password with our encrypt content, which will be the password in clear to string, and the salt, which is going to be pw salt, which is a UUID, to string. And since the result is a model result, we're going to need to get our model error, and we're going to follow the same pattern. We're going to put crypt, and it's going to be our crypt error. Now what I like to do is to have my enums in the same order as my froms. So that is just me being a little bit OCD. So I'm going to move the from SQLX at the end. And now we're going to implement the from crypt to our crypt variant with our code snippet. So now that we have that, that works fine. And we're going to do a SQL update on the table of self where we have the ID matching. And now the trick is we're just doing a data and we're creating our vector of fields with a PWD and the toString. And then the into will create the field. And then we do an exec and an await. And then we're going to return void. And here, by the way, if we over data, just to be clear, that will take a vector of fields. So that is what we have over there, which will create a vector. And then the into, there's a from the tuples that will make it a field. So now that we have that, we can bring our terminal and we're going to do a pSQL on our PG database. And then we're going to connect to our AppDB. And then we're going to do a select star from user. And we see that we do not have any password, obviously. And we have the salts, as we have said that in our SQL. So now what we need to do is go to our dev-utils and go to our dev-db, where we initialize the DB. We're going to create a constant for demo password, which is going to be welcome. And then within our init dev-db, we're going to add a section. First, we're going to init our model layer with our model manager and our root CTX. And then we're going to set the demo1 password. And now it's going to be extremely simple. We're going to first get the user ID of demo1. We know what it is. It's going to be 1000, but just to be safe. So we're going to do an unwrap, but we're okay to do that in this case of first by username because we're on the dev-utils. So if it fails, it's okay. And then we're going to do a user BMC, update the password, CTX, model manager, demo1 user ID, and then our demo password. And then we do the await and the question mark. Now we're going to add a little info trace where we're going to do set demo1 password. And so now we're going to do a cargo run quiet. So if you have your cargo watch, that will run as well. And we see that we have our trace over there. And so that means that if we have our pSQL, we're going to have to connect again to the same database because the database was dropped in a brute force. The connection that we had above is dead. But the cool thing is pSQL keep it okay, and then we just need to reconnect to the same database, and that will work. And so now that we have that, we're going to do a select from user, and now we're going to see our encrypted password with the scheme 01. Okay, so now we have everything and we're ready to do our logging. So we're going to go to our web layer in the Rust login. Now, in the API login handler, we are missing something. We don't have the model manager, the app state model manager. So what we need to do is to make sure that in the Rust over there, we're getting the model manager such as we can set it as an app state. So for now, we're just going to add that there, and we're going to fix main later. And then for our router, we're going to add with state our model manager. And then we can add our model manager as a state, the Axum state obviously, of model manager. So now we're going to have the model manager there, which will allow us to call the user BMC. So now we can destructure it with state. And that is kind of optional because there is a deref on state. So we could get the DB directly. So it works either way. But now obviously we still have our routes compiler because in our main that we are going to open right now, we are not giving the model manager. So we can fix that quickly. In our routes, we're just going to pass a model manager clone. That will fix that. So now we're going to go to the implementation, and rather to have this fake login, we're going to select it, remove it, and we're going to extract the username and the PWD, which we are going to rename PWD clear, such as we don't get confused. We get our route CTX, which obviously we need because we cannot use the user for login. We need to have the system user. And now that we have that, we can get the user. So we want the user for login with our first by username. We do the await, and then we are going to do a OKR login fail username not found. Now, there's a very important point here. We do not want to log the username anywhere. We want to forget about it. And the reason why is because sometimes users enter password as their username. So it's very important that when there's a wrong username that is not found, you don't capture it because you don't want their passwords inside your log files. So in this case, we just do username not found, and we won't be able to debug why it's not found, which is completely fine for the sake of the user. So now that we have that, we're going to do our imports. And then the first thing that we're going to have to fix is going to be the question mark. And that is because it comes from our user BMC, which is our model layer. And in our web, we're using result, which is from the web layer with a web error. So for that, as usual, we're going to bring the web error, and we're going to add a section, modules, we're going to add our model. And then the same thing, we're going to add our froms, that is going to be model variant, and then we're done. And then next, we're going to add the login error that we have. So now that we have that, everything has been fixed, and we can get our user ID because we're going to use it later. And then we're going to use a let else pattern to do a guard on the password. And that means that if we don't have a password in user password, we're going to return an error, which is going to be user failed, user has no password. And now we can give the user ID because we have the user ID. And that doesn't have any critical information. We're going to go to our web error, and we're going to add this variant. And also we're going to add the next one, which is going to be a login fail, password not matching. So like this, we have both. Now, one thing that I like to do in my enums for my error, I like to use variant struct rather than variant tuple. So this way, it's extremely clear about what is a value. And then there's an exception to that. And that is when the variant goal is only about holding the value of the name of the variant. So that is true for all of our errors that we are encapsulating, like the CTX extractor error that we're going to talk about later, or modules error. So in this case, a tuple variant is actually a very good fit. So now back to our code, we have everything that works fine, and we are ready to do the validate. So for the validate password, we're going to call the validate. We're going to create our encrypt content with a salt, which is a user, salt, and then the content, which is a password clear, clone. And then for the reference password, that is what we got over there. And because it was a let else pattern, we get that now as a PWD variable, and it's a string. So we can give a reference of PWD. And now, in this case, we could put a question mark over there, but that will return a crypt error. So what we're going to do is we're going to map it into our error for login fail, password not matching, and then we're going to have our user ID. And then we put a question mark. So now that we have that, we can bring our quick dev, our backend terminal, and our quick dev terminal. We're going to comment out the do get index HTML. We don't really care. And we're going to do a cargo run of our server, or you can do the cargo watch. And then on the quick dev terminal, we're going to do the cargo watch of quick dev. And we can see our response body, which is success true. We can see that it set the fake token over there. So everything works fine. And this was obviously for our API logging post. And on the server side, we have our trace, which is our API login with our request log line. And that is our API login. for our API login handler. So everything is working fine. Now, if we were going to put a wrong password, press save, then we got a service error over there, which is what we want on the client, because for now we didn't map it to what we want to send. We will do that later. So by default, the client get minimum information, but on the server side, then it will get the whole information about why it failed, and we'll have that in our request logline. So now let's say that we want to have the correct service error on the client side, not as detailed, but saying that it's login fail without giving the reason. So for that, we're going to go to our web error. We're going to take these 3 variants. So that is our server error. And then we're going to see that we have a client error. So that is what we did in the Rust Axum course, where we split the client error, what is going to be sent to the client, from the server error. And so if we go there, we're going to see that we have this function, which is a client status and error. And we have this match that will translate the server error to whatever we want to send on the client error with the status code. So here we have one for the CTX extractor. We'll talk about that in the next chapter. And then we have our fallback, which is our service error. So that is why we always get a service error if we haven't added anything there. The point of this design is that the lazy path is a safe path, where if we don't put extra work, then we don't put the system in extra risk. Now we can do explicitly, we can say find to send login fail. So for that, we are going to split actually our section between auth and login, and we're going to add that. So basically that means that if the error match any of those variants, and we don't really care about the values, then we're going to turn the status code of forbidden and our client error login fail. And in client error, we already have our login fail, and so we are all set to go. And we are pressing save again. Make sure you restart your server. And now we're going to have a login fail. That's it. Very simple and very safe. And then we have our server with all the information and the request log line with all of the information. And that is it for this chapter. So what we did in this chapter, so we did the user for login, and we did the encrypt and the validate. And in the next chapter, we're going to do the create token that we're going to set in the cookie, and then we're going to update our auth resolved to validate our token from the cookie. So now let's go to chapter 8, which is going to be our secure token and web authentication. So first, let's do an overview of what we have done. So far, we have done the user for login, the encrypt, and the validate. In this chapter, we're going to do the create token, and that is going to be about creating a token of this format. So it's going to have 3 parts: username, expiration, and signature. All of these parts will be B64 URL encoded, and the reason of it is that we want to have this token being as portable as possible. So right now, we're just going to put it in the cookie, but later it could be used for a reset password, for example, or even signing URLs. And in fact, the first part, where we say username, is more an identifier of something. So in our case, in the case of a web token, it's going to be the username, could be the user ID, could be the user UUID or whatever, it doesn't really matter. But that is the identifier of the entity you want to have a token for. So in a web token, the whole thing is about having a token for a user session, a user authentication, but we can use the same scheme for other things. So for now, since we are going to talk about the web token, that is going to be our username. And so we're going to put that in a cookie, auth token, and it's going to be HTTP only, meaning that the JavaScript won't have access to it. So our strategy is to completely decouple the authentication part from the authorization part, meaning that the token doesn't have to have any payload about the authorization of the user. It just has to make sure that the user has been authenticated and nobody can tamper with this part, the username or the expiration. So then where the token is going to be validated on each request is going to be now auth resolved, or middleware CTX resolved. And what that will do is it will call the first by username and get a user for auth structure. which has the ID, the username, and the token salt, which is like our user for login, but without the password and the password salt because we don't need it. So for any of the requests that are not statics, we have the auth resolve middleware. And you could also put it inside the static request, but right now it's for everything that is not static files. And the point here is that even if it doesn't create the CTX, it will not fail. So that is safe to put in front of anything, API login or whatever. So the auth resolve, the way it works is once you have the request that comes in, the auth resolve will get the auth token from the cookie. It will extract the 3 parts, and then with the username, it's going to get the user for auth from the database. That will give the token salt. And now with the token salt of the user and the token key at the application level, it can validate the signature. So basically redoing the signature of username and expiration and making sure that it falls back to the same one. Then when that passes, it means that nobody modifies username of the expiration, and then it's going to validate that the expiration is still valid. That basically the now is not greater than the expiration. It's very important. We're going to create a new one, a new token, because otherwise the session of the user will expire after a short amount of time, or you will have to do the expiration very big, which is not very safe. So what you do is you try to minimize the window of the expiration, and then every time the user requests something or goes to the server, you update the token. So that will update the cookie on the browser side. So that is very standard practice. So then when we create the new token with a new expiration, and since we have the token salt, we can sign these 2 parts and have our signature, and then we send it back. Now, it's important to note that the expiration is different than the expiration of the cookie. So in the cookie, you are going to have an expiration that usually will be the same or a little bit greater than the other expiration. But this cookie expiration, while it's important to make sure that the browser keep the token long enough so that the user doesn't have to re-log in all the time, it doesn't really matter from a security standpoint because the source of truth is what is in the token, this expiration. So that is what gives how long this token is valid for. And nobody can change it because otherwise the signature wouldn't match. And again, the cool thing about this pattern is that this token is quite generic. We're using it for web authentication, but it can be used for anything. Now, the first thing that we're going to have to do is manage all of the time formatting in string and parsing and so on, and the base64 as well. So those are good candidates to be part of our application utils module. So we're going to start that now. So we're going to go to our main, and in our main, we're going to create our utils module. And that, as your application code grows, that will grow quite a bit. And those are the generic utils that doesn't really fall into a specific module. And so time and base64 are good candidates for that, obviously, but eventually you are going to have more. So we're going to make it a utils mod.rs. So now that we're going to drill down into it, and there's going to be a couple of libraries that we're going to use. We already have the base64 URL, and we're going to add time library. You could use Chrono, we're standardizing on time, either way works well. Because we're in a utils module, we're going to follow our best practice. We're going to have a code regions for modules, and we're going to have our error. So like this, we have our clean utils error. We're going to re-export it as usual, and we're going to create the files. And then with our little code template, we're going to create the placeholder so that everything compiles nicely. Now that we have that out of the way, we're going to use the time library, and we're going to use a profile of ISO 8601, which is going to be the IFC 3339. And then we're going to use from time, the duration, and the offset date time. So now we can create a code region for our time. So we'll have a code region for time and a code region for base64. Eventually, some of these utilities might go to their own submodules. So now we're going to do a little bit of silly functions, which is going to be the now UTC that will just return an offset date time, and that will just call that. And then we're going to have a format time. So this one is very simple as well, but quite useful because that is where we're going to normalize which ISO profile we're going to use. So in this case, we're using the IFC 3339. So the application code just calls the format time, and then we will normalize everything with this profile. Now, We are again breaking our rules here where we're doing an unwrap because we want this function to be as simple as possible to just return a string. So right now, I think it cannot fail because this time is time that we will produce anyway, but I'm going to mark it as a to-do to make sure that that is safe, such as it won't fail. Now, on the to-do, usually I have two kind of levels of to-dos. I have the to-do like this, where I need to look at it at some point. And then if I want to increase the priority of it, I call it fix me. So those are the two types of priority. So fix me means the application shouldn't run if we don't fix it. And to-do is something that really needs to be looked at, but the application could run without fixing it. Obviously, that is a personal practice right now. Make your own. As long as you are consistent, it's completely fine. And now we're going to do another one, which is very specific to what we need. And it's going to be a now UTC. So we always have the UTC and plus the second, and then we'll return a string. And that will take a second and F64, which is going to be in our format. So for that, we're going to use the time API. We do the now UTC plus the duration, and then we do a format time, which is obviously what we have over there. Such as, again, everything is very normalized. It's starting to look pretty good. And we're going to have one more, which is going to be the parse UTC. And again, we want to make the application code as simple as possible. So we're going to have the parse, which will take a moment, which is just a string, and it will return a result of offset time, because this case can fail quite a bit. And obviously the result will be the result type of the utils because we have our own result and error for utils. So now we have our offset date time and we just parse with the same profiles that we have over there. So this way, everything is super consistent. So now obviously the parse has a different error. So we're going to map the error with our utils error, which is going to be date fail parse. We're going to give the moment as a string. And we don't really care about the reason. We're just capturing the strings that cause the problem. And then that will be enough. If you need more information, those things can be changed. So now we're going to have create the date fail parse. We bring our error. We're going to have a section for everything time. And then we're adding there. And in this case, I'm putting it as a tuple variant because it's clear enough, but that could be a variant struct as well. So now it's pretty cool. We have all these functions that manage our time, such as everything is very well normalized. Now, because they are very small, there's a little temptation of adding an annotation like that inline or inline always. And all of the literature that I've read says that the compiler knows better. So except if you really know what you are doing, you can add those annotations. Otherwise, let the compiler do the right choice. Now let's do our base64 functions. And that will be the b64u encode. And that will just be a pass-through with the base64 URL encode. And then we're going to have the decode. And the decode could fail, obviously, so we want to have a result. And then we're going to have our decoded string. We're going to use the library base64 URL. We're going to decode it. That will return a result of vector of 8 with the decode error. And we don't really care about what the error is. We just want to capture that it failed. So what we're going to do is we're going to do a OK, which is going to turn that as an option. So now we have an option of vect 8. And because we want to have a result of string, we're going to have an and then, and we're going to take our vector of 8, and we're going to do a from UTF-8, and then we're going to turn that as well as an option. So that's why we use the and then. So now that we have our option of string, if we have none, we want to return an error. So again, the strategy is that we do not care about the error. We just care to say if it fails or not. So we're just going to say OK or, and we're going to return our own error, which is going to be fail to b64u decode. And then we do the question mark. Now, obviously, we need to create this type. And in this case, we're not going to capture the text. We could, but because it's going to be used everywhere, I don't want to capture these things because then it can be logged. So now that we have that, we get our string back. And now this is when I remove my to-do and I do a OK decoded string. And now if I go to my crypt and I go to my mod.rs, we can start doing our token module. So we're going to create it and we're going to get into it. And that is going to be where we have the whole logic about the token. We're going to parse it, create it, and validate it. So we're going to use a config because we need the key. We're going to use a crypt error and result. And the first code region is going to be our token type. And then we will have our web token generation and validation. So that will be for the web token. But in fact, again, the token is quite generic. So we're going to have a code region, which is going to be private, which is going to be for token generation and validation. So in this code region, we're not going to know the specific of a web token and all these kind of things. And in the web token, we will know which keys to take and assumption to make to create the token. So that is how we're going to split it. And eventually that can go to sub-modules. Right now it's going to be relatively simple, so we can have everything in one file. Okay, so let's create our token. It's going to be a struct token. And the string format will be what we have seen before. So these three parts. The first one will be the identifier, which for web token will be the username. Then it will be the expression as string. So those will be the decoded ones. And then we have the sign B64U string. So the first one is the identifier, which will be the username. The second one is the expression, which will be in RFC 3339. And then we have the signature, which will be in base64 URL. So the reason why the signature is base64 and the rest is decoded is because the signature is just a black box. We're just using it to match it. The reason why it matters that it's base64 URL is such as it can be put anywhere and we don't have some weird characters. But outside of that, we just need to match it with a previous signature. So that's why we just need to care about the base64U when we do the match, as long as we're comparing the same encoding. So now that we have that, we're going to make two fixed me's that we're going to do later, the from string that will do the parse and the display to string. And we'll do that later. Now, if we go to our private token generation and validation, we're going to have a generate token. And in this case, I'm going to start the function with underscore because it's private and because it's going to have the same name as a public one. So that is one best practice that I have, and it's really a personal preference. I don't always put underscore in private functions, except when their name match the public ones. So you could do that. Another way is to say generate underscore token underscore inner sometime, but that might have other meanings as well. So we're going to follow this best practice, which is when we have the same name, we have the underscore. So the goal of the function is to return a token, a result of token, and it will take an indent, which could be username in the case of a web token. It will take a duration in second. So again, make sure to always have the suffix for the unit of the duration. It's going to take the salt, but it doesn't have to know if it's a user salt or another salt. Just take one salt. And then it will take a key. And again, it doesn't have to know where the key comes from. It just takes the key. And because we need to sign and so on, we're going to do the implementation later. And we're going to have another function, which is going to be token sign into base64U. That will return a result of string, which is going to be base64 URL format. It will take the indent, the expression, the salt, and the key. And so for this one, we're going to add a comment, which is going to be create token signature for token parts and salt. So now that we have that, we're going to create our validate token signature and expression. And that will take the origin token and the salt and the keys, such as it can re-sign it again. So that will first validate the signature is okay, and then it will validate that the expression is not greater than now. So now that we have these placeholders, we can actually do the full implementation. So for the generate token, it's going to return the result of token. It's going to take the username, and the salt, and then we'll get the config. And now we can just call underscore generate token with the user, the duration from the config, the salt, and the key. And then we can do the same thing for validate token, which is going to take the origin token, the salt, and the user will get it from the origin token and the expression as well. So we get the config, and then we're going to call our validate token with the origin token, the salt, and the key that we get from the config. So that's it. That is our web token generation and validation. Now, the reason why we delayed the implementation of the private functions, because we need to implement the display and from str. Let's start with the display, which basically will give us a toString. So we're going to do a implement display from the standard library for token. we're going to do the lazy way. And here's a little technique that I use when I do parsing or serialization. In this case, it's relatively simple, but sometimes you want to check and have a very quick iterative way. So below, on the same file, I'm going to create my unit test, and I'm going to do a test of token display. Okay. And now I'm just going to have, for the fixtures, I'm going to create a silly token with whatever string I want. It doesn't really matter. And then I'm going to exec, and I do my debug print with my little prefix over there. That will print whatever the display is implementing. Now that I have that, I can bring my terminal, and I'm going to do a cargo watch, quiet, clear, execute, test, and then I'm going to do my test token display. I could have said display OK is the same thing. So now that I have the no capture, if I run that, it's going to fail because we have our to-do in our implementation. So that fails. But now, if I do a write hello, for example, we have our println hello. So now I can iterate very fast like that. And I have that below, and I can just write my code, press save, and I see where I'm going. And then eventually, I do the assert and remove the print. So in this case, we're going to do the write. We're going to have our 3 parts, and we're going to do the base 64 encode of the 2 first one, and we're just going to take the latest one. Make sure you import the function b64 encode. And now, if you press save, then you get our print over there, and you can check that it kind of makes sense. And if we're OK with it, we're going to take it, copy it, and then go to our unit test, and we're going to add a fixture with our token str, and we're just going to do an assert equal of the 2. We print save, it passes, and then we can remove our println, and then that's it. That is what I do a lot on these little functions that have parsing or serialization or whatever, such as it helps me code faster, and then at the end, I have a free unit test. Now, to be exact, this is not exec only, it's exec and check, if we really want to be OCD here. Okay, so now the next one that we're going to implement is a from str, which is going to give us the parse. This one is going to be a little bit more advanced. So we're going to do implement from str for our token. We do the implementing missing. Our error will be our crypt error. So we will add some. And then if we go to our from str, so we're going to actually add the error right now. So we're going to have an error section for token. And those will be the token invalid format, token cannot decode indent, and token cannot decode expiration. So now that we have that, we're going to rename S to token str, just to be clear. And we're going to first split it with the dot. And if we don't have 3 elements, we're going to say invalid format. We could use regex, but in this case, that works perfectly fine. And then we're going to do this one-liner just to extract the 3 elements. And then we're going to return an OK of self, which is going to be the decode of the indent. And we're going to map it to our error that we just created. Make sure to import the decode. And then we're going to do the same thing for the expiration date. And then we're going to take the signature, which is in b64 format. And now we can remove the to-do and the semicolon, and then that's it. Now, just for completeness, we're going to do the unit test. I could have done that live as well, but we're going to have our test, token from str, okay. Our fixtures, we're going to take what we had before. We know where we want to land. And then we're going to exec it. So we are taking the token string, parse it now. So that is a nice thing with API. And because we have the token type, everything works. And now we're going to do our check. And we could do an assert equal like that with token and fx token. If we press save, we're going to have an error. And the reason why we have an error is because token doesn't implement partial equal and doesn't even implement debug, which is needed when you do that. So if we bring our token code that we have above, we could add a derived debug and partial. And if you press save, that will work. But now the things that I don't really like, and that might just be me, is that the partial equal is a trait and a macro that you are using in your normal code when you want to compare struct. So it's a useful thing to have in normal code. But in our case, we're not using it for our application code. So it could be misleading because we could think that we're using it to compare tokens, which we are not. we're just using partial equal just for unit test. So I'm not really a big fan of that. And debug is a different story because the name debug is very clear that the intent is for debug. So I'm okay to have debugs in my code because it might be useful for print or unit test and so on, but partial equal is a misleading thing because it's something that might be used in a normal code path. So that, by the way, might be just me. So what I like to do is I'm going to keep the debug, but I'm going to remove the partial equal because I'm not using it in my normal application code. And now the trick that I'm using, and that might look very ugly for some, and if it looks ugly, don't do that. Use the partial equal, it's completely fine. But the trick that I like to use is I'm using the debug formatting as a comparison frame. So I'm going to format the token and format the fixture token with the debug notation, and that will go 99% of the way. But this is really a personal preference. Do what you think or what your team think is right to do. The important thing, again, is to write unit test. And now that we have this unit test, we can bring our terminal and we're going to do a cargo test and we're going to test everything under Crypt. And then that's it. We have our 3-pass test for token display and token from str. Okay, so now that we have this token type done, we can go back down and implement our token generation and validation. But the first one is going to be generate token. And we have our indent, the duration, the salt, and the key. So we have everything we need. So we're going to compute the 2 first components. We're going to take the indent, which is going to be a string. We're going to take the expiration date. And so we're going to call our time utilities to add the duration in second. So that will be a string as well. And now we're going to sign the first 2 components. And that will be by calling the token sign into B64U. And now we can just return our token, which will be our indent, expiration, and sign B64U. Make sure to import a function. And now we have this function done. So we can implement the validate token signature and expiration. For that, we're going to add a couple of more errors variant. Token signature not matching, token expiration is not ISO, and then token expired. That will be the 3 types. So we're going to validate the signature first. So the way we're going to do it is we're going to sign it with the origin token indent, the origin token expiration, and then the salt and the key that is passed. But that is not part of the token struct, obviously. And then we're going to compare these new signatures that we're just getting with the one which is in our origin token. So as we can see, we don't need to decode the B64U, we're just matching it. And if it's not equal, then we're returning our error because it means that someone changed something there. So now that we have that, we're going to validate the expression. And to validate the expression, we're going to do a parse UTC, which is our utility, from the expression date, because now we know that it hasn't been tampered. If the parsing fail, we're going to return our crypt error that says that the token expiration is not ISO, so there's a formatting problem. So that's why we have the question mark. And then we're going to get the now UTC. We're going to compare the 2 dates. And if it's not okay, we're going to say token expired. And if it's okay, everything is good. Make sure to import the utils. And so now the only thing that we need to do is our token sign. So we have all of the arguments that we need. And again, we don't know about web token in this case. It's just generic arguments for our token scheme. So we're going to create the content to be signed. So we're going to keep the same format that we had on the serialization, which is the 2 parts. And then the 2 parts will be base64. And then we're going to call our encrypt. We're going to use the same encrypt method that we have. If you want to be more performant, you can also use just SHA-512 pass without the hash mark. That is possible as well. And in this case, I will recommend to still use the salt and even the keys as salt in a way. Keep the same model regardless of the implementation details of the encryption. So right now we're going to use the same one. So we're going to give the key and our encrypt content, which is the content in clear and the salt. Make sure to do all the imports. And now we can just return the OK signature. And by the way, on the content, my strategy was to still encode each part as B64 URL encoded. That is kind of optional. It could have been just the indent and the expression. But this way, if I wanted to just check without even decoding, that would have been possible. In our case, we are decoding anyway, so it's not really useful. And that is important to note that is completely unrelated to the final base64 URL encoded of our signature. And that is what you want, because again, you want to have the signature as portable as possible. Now that we have that, we're going to write some unit tests. And again, the goal is not to have 80% coverage at the beginning, but to have the key unit test to make sure that things kind of make sense. So we're going to test the validate web token OK, our fixtures, the user doesn't matter, the salt doesn't matter, the duration, we're going to make it at 20 milliseconds. We're going to see why later. And then we're going to have our token key. We're going to take it from the config. Then we're going to generate our token as a fixture. In this case, there will be an argument to say, well, we should have a full token already generated and hard-coded there. But so far, that will work pretty fine. We're going to exec. And what we're going to do is sleep for 10 milliseconds. So we're not past 20 milliseconds, so everything should be fine. Then we're going to validate our web token. And then we're going to check. And the check is just a question mark. So we're going to import the thread from the standard thread and the duration. And this is not an async function, it's just a normal test. So if we look at our types over there, that is all our fixtures. We have our token key as a vector of 8, and then we have our token as a token type. That is the way it works. So everything is working very nicely. And now we're going to do the expiration test. And that is very important to do early because you don't want to think that your validation works and it will never check the expiration date, for example. So we're going to check that right now. So we're going to follow our convention. We're going to do _r, and we're going to add a suffix, which is expired. Now, we're going to change the duration to 10 milliseconds, and then we're going to sleep for 20. So now that should fail. So what we're going to do now in our check, we don't want to fail the test if it fails because we want the rest to have an error. So we're going to replace it with the assert macro, which is just asserting a Boolean. And then within it, we're going to have the matches macro. And the matches macro will match the result to this enum. And then if we have this error, we're going to print this message. So very simple. So now if we do a cargo test crypt, we see that everything passes. So sometime when it passed the first go, which happened a lot in Rust, I'm so paranoid I'm going to change it to make the unit test break, and then I put it back to make it pass. But in this case, you can trust me, I've already done that. Okay, so now that we have the token done, we're going to go to our web mod.rs, and we're going to add two functions, set token cookie and remove token cookie. So our set token cookie is going to return a result of void. It's going to take the cookies in, and then the username and the salt. We'll generate the web token, and we're going to create our new cookie with the auth token, and we're going to set it as HTTP only. So that will increase the security. The JavaScript won't be able to access it. And then the very important part is to put the path as root. Otherwise, by default, it will set the path of the API login folder, and then you are going to spend quite a bit of time to try to debug on why it doesn't work or why it doesn't log off and so on. And then we're going to have our cookies add. Now we're going to import. So the cookies is from the tower cookies. We're going to import our generate web. And the cookie type is also from the tower cookies. So now the generate web token return a result, which is not the same of this one, because it's from the crypt module. So same as before, we're going to open our web error. And then in the modules section, we're going to add crypt error. And then we're going to add our from with our little code template. Crypt, and done. And then that's it. We have that. That's getting fixed. And now we can go to our routes login. And our API login handler, we're going to go down. And where we have the fix me, we're just going to replace this line with our web, set token cookie, the cookies, the username, and the salt. And now we can change the comment, set the web token. So let's go back to our request flow to know where we are. So what we just did is the login handler, this one. And so now we set the right token over there, the fully encrypted one. And now what we need to do is making sure that in the auth resolved, we're going to take it and validate it. So that is what we're going to do now. And then eventually we're going to be able to do the API RPC with our auth require. And that won't really need to be changed because we already have the logic over there. So let's go back to our auth resolve. And for that, we're going to go into the mw_auth.rs. So we have the CTX require, and then the CTX resolve, and then the CTX extractor. So the CTX resolve and the CTX extractor work in pair in a way. So the CTX resolve will resolve the CTX, so it will create it after it validates the auth token, and then it will put it in the request extension, and then the CTX extractor is going to pluck it out. So we're going to see that later. And then we even split out the CTX extractor result and error so that the main web error doesn't have to have clone and all of these things that are more specific to extractor only. So that's a nice way of splitting out the extractor error. And we're going to see that later. So now if we look at our CTX require, it's extremely simple. You just take the CTX and do a question mark. And the result is a result of the web layer. And it's a result on CTX. And obviously the content is CTX. So this middleware just check that there is no error in the CTX. And otherwise, it will return early. And then we have our CTX resolve. And that is where we're going to do the heavy lifting of doing the token validation. So that is the old implementation, which is a fake one, but we're going to change that. That is the expensive part, where we're going to have to use the model manager to access the database to get the user for auth. And then obviously we have the tower cookies, such as we can set the cookies. And then we have our request mutable, because we're going to use it to set the CTX result. So now to better understand how it works, let's look at the CTX extractor. So it's just an Axum extractor for CTX. And then inside what we're doing is we're going to take the parts, extensions, and we're going to do a get on the CTX exe result. So that is what the CTX resolve will put into the request. And so that is the same pattern that the cookies from Tower Cookies uses. You do the expensive part once, and then you put it in the request as an extension, and then you have the extractor that just pluck it out. So then when we do the get CTX exe result, that will return an option. And so if there is no CTX exe result, we want to fail early and return an error. So we're going to do an OKR, and then we're going to have our web error, which is going to be a CTX exe variant. And then we're going to have this error, CTX not in request extension. So this way we're capturing the error in case there is no CTX exe result in the request extensions. And so we do our question mark to return early the web result. And then if we pass, we're going to clone, which is going to clone our CTX exe result, which is what we want because we want to return a result of CTX. And then we're going to map the CTX exe result error into a web error. So that is what we're doing over there. So like this, everything is clean, is returning a web error for this extractor. And the web error has a CTX exe variant. And then if we look at it, we can see that it's just a wrapper on top of our CTX exe error. So it's a little bit of a mouthful, but it's actually relatively flexible. And we split away all of the extractor CTX information while keeping all of the errors, allowing the CTX resolve to not fail, but still capture all of the possible errors that we might have. So now that we have that, we can look at our CTX extractor result and our CTX exe error. So those are just the variant of this enum, that is the error. And this is not even a full error with a whole boilerplate. So we just have the clone. We make sure to have the serialize because those will need to be serialized for the server request logline. And then on top, we just have a type alias for the result of CTX of this error. So now that we have that, we can implement our CTX resolve. And the way that we're going to do it is we're going to have a private function, an inner function. We're going to follow the pattern that we have, which is the underscore CTX resolve. And the goal of this function will be to take the model manager, because it will have to get the user for auth, then the cookies from tower cookies, and then it will return a CTX-EXT result, which the MW-CTX resolve middleware will put in the request. So this way we can use a question mark in this function, and then on the parents one, the CTX resolve will do the rest of the logic. So now, here's what we're going to do in this function. We're going to get the token string, parse the token. We're going to get the user for auth from the database. We're going to validate the token, and then we're going to update the token in the cookies. Again, we want to update it such as the session doesn't expire, and we can keep the expiration window relatively small. And then we're going to create the CTX-EXT result, such as our CTX resolve can put it in the request extension. So it will not fail, it will not break if that fails, but it will capture all of the errors. So to get the token, extremely easy, we're going to get the cookies, and then we'll do a get auth token. Then we're going to map it to a string, and that will return an option of string. And if we have none, we're going to return the token not in cookie, question mark, to return early. So far, so good. So that will give the token as a string. Now, we're going to parse the token. So we're going to shadow the token variable, and we're going to define the token type, and we're just going to do token parse. Now, we're just going to do a temporary unwrap right now. We obviously do not want that. We're going to fix that shortly later. But I just wanted to add a little note. So in this case, we start from a string, and because our token type has a from str, we can use parse, and the compiler will know that the parse is supposed to return a token. Now there's another way of doing that is to use turbofish, and that is we don't put the type over there, but we're putting it over here, and that is completely fine. So that is really a preference at this point. So for this case, it's more kind of a personal preference. In my case, sometimes I like to have the type on the left, but I'm not too dogmatic about it. So now obviously we do not want the unwrap. That will go against everything we are trying to do. So we could put the question mark, but in this case, because that is a crypt error, and we need a CTX result error for our CTX extension result, that wouldn't work. And we don't really want to have crypt as a CTX extension error. So what we're going to do is we're going to do a map error with a token wrong format. So that will be enough for us. And again, in this case, we don't really want to capture what the token is because we want to be extremely safe, but there will be an argument that it should be okay to capture it. But right now I'm erring toward the safety, so I'm not going to capture it. So obviously we have to create this one. So if we open the one below, just putting it there, and that will be a token wrong format. And in fact, we're going to add a little bit more variance that we're going to need later, which is user not found. And again, here I'm not capturing the name. And then we have our model access error if something happened when we do the database connection. And in this case, I'm making a little exception is I'm using string rather than the model error because I don't want to have the full model error over there. But that could be arguable. And eventually, if you need to have this type of information, just have the model error over there. So then after we're going to have the fair validate and then the cannot set token cookie. Okay, so now we should be all set with our CTX extension error. So that compiles, so we're all good. And now we're ready to do our get user for auth. So we're going to use our first by username with root CTX because obviously we don't have a user. And then with our model manager and our token indent, which is the username. That will return our user for auth. We do the await. If there is an error, a SQL access error or something like that, we're going to map it into a CTX ext error. And in this case, as I said before, we're just going to do a toString on the model error. We can change this strategy later. That will be an easy refactor to do if we need to have the full type version of it. So now, because our first by username is going to return an option, and we want to make sure that we have a user, we're going to turn our option into an error with OKO, and then we're going to do our CTX ext error, user not found. And then we're going to do the question mark to return early. And again, in this case, I'm not capturing the name, just in case, but because it's a token, the probability that it comes from a user input is extremely low. But anyway, I'm being ultra safe here. Making sure to import the user for auth and the user BMC. And now we can validate our token. So the validate web token is that simple. We're just doing a validate web token, and we are doing our map error. We make sure to import it, just take the token, and the token sort that we got from the database to string. And now if we are at this point, we have passed the validation, and we need to update the token to make sure that the session can continue. And so we're going to do a set cookie. We give the username and the same token sort, and that will set the new cookie. And in case of an error, we map it to cannot set token cookie, making sure to import it. And then we are all set to create our CTX-EXT result, which is independent of the web layer. So that's why there is no cookie or token or whatever. It doesn't really matter. Now it has passed. And so we're going to create our CTX, new, the user ID, and that can fail because if the user ID is 0, then it will fail. And sometimes it might fail for other reasons when we have more advanced CTX new. And so we're going to have a map error of CTX create fail. And so we're going to do an ext to string again and just have a string. Okay, so now we have done the hardest part, so we can go back up. The CTX require is all done, nothing is changing over there. And then the only thing that we're going to change is in our CTX resolve. So now we're going to use the model manager. So we're going to remove the underscore. And we're going to select all of that. Delete it, we don't need it anymore. We're going to get our CTX-EXT result, which will be a result of CTX and CTX-EXT error. Now the important point is that the CTX resolve shouldn't fail if there's a failure of the CTX resolution, because that is the responsibility of the CTX auth or other things downstream. So it's very important that we do not put a question mark over there. And one production optimization we want to do in this function is that if we have an error on the validation of the token that comes from the cookie, we want to remove it from the cookies because we don't want to keep validating the same invalid token over and over, because if it is invalid once, it's invalid all the time. So we're going to do a if CTX-EXT result is error, and if it's not matching, token not in cookie. If the token is not in cookie, we don't need to remove it, but if it is, we're going to remove it. So that is what we're going to do like that. So it's very simple, but this way you are giving a little bit slack to your server where it doesn't have to revalidate invalid requests all the time. And now that we have done that, we can store the CTX-EXT result into the request extension. So we're going to do a rec, and we insert our CTX-EXT result. And that again is an insert by type. So it's unique by type, which is completely fine in our case because we have our clean type just for our CTX-EXT result. So now this function didn't fail, but capture all of the information of the authentication. If it fails, if it passes, and everything else. So now that we have that, we can test it quickly. And we're not going to do a unit test. We could do a unit test, but right now we're going to do it the quick dev way. So we're going to go to our main, and we're going to add back our route hello. And that is going to be route hello, that's just going to return hello world. And then we're going to have a route layer of our middleware, the CTX require. And so we are making sure to import everything we need. And now we still have the red line because we need to add it to our routes all. So we add it like that. Our middleware for the CTX resolve already had the model manager state, so we are all good. And now we can bring our quickdev.rs, and we're going to do our client do get on hello after the login. We're going to bring the server and the quickdev terminal. We're going to do a cargo watch on the server side, cargo watch on the quickdev side, and then everything is working nicely. So we have our response hello world. We can see that we have our cryptic auth token that has been set, because for every request we set it again. We refresh the cookie. And then if we go back up, we see that we have our API login that set the initial token. So everything is pretty good. And then that has a success true. So everything is looking pretty good. And on the server side, we have this trace for the hello world, and everything is working nicely. The MCTX resolve has been called, and the CTX required has been called as well, and everything has been good. So that's it. And if we check the first one, we have the API login handler that only has the CTX resolve, because even for login, we do it anyway, because this way in the log line, we can capture which user is calling what, even if it's login or log off. But because it never fails, even if you're not logged in, you can log in. And now we can have a little fun, so we can put our do get hello before the login, press save. The login, which is a second request, succeeded, but the hello was before, and we got the no auth on the hello request. And on the server side, we can see that the API login was fine, it was a second request. And the first one, we get all the trace. And in the request log line on the server side, we get a client error, which is what we're sending to the client. But we also get the full error of why it failed. And that's it. And by the way, as we have seen in the Rust Axum course before, everything is linked by UUIDs. So you have the rec UUID, which links everything. So then after you can debug things very nicely. And most of this magic is implemented in the web error and in the MW response map. And we're going to see that later. But that is what we did in the Rust Axum course if you want to look at it. Okay, so now we can implement our logoff. And that is going to be relatively trivial. So we're going to go to our routes login. So that will be for both. In our routes, we will add another route for logoff. So let's implement the handler first. We're going to put the login in its own code region. And then we're going to create a code region for logoff. So the first thing that we're going to have is a logoff payload. And it's going to be a silly one with just a flag, which is logoff, which it will always be true probably. The reason why we want to do that is because we want the logoff to be a post and we want to have it a JSON as well. So long story short, and I don't want to go too deep into that, but application JSON posts are pre-flighted by the browser, meaning that they have some protection for cross-site scripting. So by making our post an application JSON post, by taking a JSON in, then we're making sure that it will require the content type application JSON. So that is a little trick. There's probably other way to do it, but this is a nice one. So now there's another method that we need to do is a remove cookie. And so rather to set it there, we're going to go back to our web mode. And for symmetry, we're going to make it in the same place that we have our set cookie. So it's going to be very simple. Let's remove cookie. We're going to take the cookies. We don't need anything else. It's going to return void. And then we're just going to create our tower cookie with named, since we don't need a value. And we do not forget to set the path /. And that if you forget that, again, you are going to have a little ride of trying to debug why logoff doesn't work in some cases, and it can take quite a bit. And then we're going to do our cookies remove. And that's it. So that is what I like. Usually I like to have symmetry like this. So even if remove token cookie is only something for logoff, I put it there because it's part of the pair. So now that we have that, we're going to write our API logoff handler. It's going to take our cookies, our JSON payload, which is a little bit silly, but useful. Then we're going to have our debug trace. Then we're going to get our logoff flag, which again is kind of a weird thing because what's the point of posting a logoff if you say logoff false, but we're getting the value in other ways. And so I'm respecting the flag here anyway. And then you say if true logoff, we're going to remove the web token. And then we're going to return a success body, which is going to be this format. And now that we have that, we don't forget to do our OK body down there. And now we go back up, and in our routes, we just add this one, which is going to be a post API logoff handler. And now, if we bring our quick dev, and we're going to put the hello after, we're going to check that it works. And if you run the quick dev terminal, we're going to see that everything works. So far so good. And then if we do a logoff just before the hello, but after the login, we don't forget to execute the request. And now if you press save, we're going to get our no auth, the same no auth that we had if we didn't log in. So that's it. We're going to comment this one out to make sure that it works. And now we're back to normal. Okay, that was a pretty big chapter, but a pretty cool one. So we have done our create token. We did the full auth resolve with a web token validation. And then we did the full login and log off. So now we are starting to have a very strong base for a real production application. Okay, so now that we have everything set up, we can do our chapter 9, which is going to be our JSON-based RPC for the task CRUD API. So what we have done so far is we have done the login log off with the auth resolve. And now we're going to do the API RPC, the handlers, which is going to use the CTX require that we have already done. So for our API RPC, we're going to use JSON-RPC. But what is JSON-RPC? So if we step back, today, there's 3 popular protocols when you want to have a client, which could be a browser, a mobile app, or another web service, talking to your service. You have the REST protocol, which is probably the most known and the most used. You have GraphQL, and you have gRPC, which is a Google RPC, which generally uses protobuf. And then you have a less known one, which is just a variant of REST with an RPC layer on top of it. And it's actually extremely simple, and it does solve quite a bit of problem. So today, we're not going to talk about GraphQL and gRPC, and then we're going to implement our API with JSON-RPC. But first, let's have a quick introduction to REST, such as we can better understand JSON-RPC and how close it is to REST. So in REST, when you want to implement your CRUD API, which is create, request, update, and delete, you generally have your create method, for example, that is a HTTP post on an endpoint, which is typically you have a prefix, for example, API, and then you have the name of the entity, plurals, and then you are sending your data in a JSON format, and then you will receive the data in a JSON format. So the API can send the whole data back or the partial data back, or sometimes the choice might be to just send back the ID. So that is an implementation detail, but the point is you have a post on the endpoint of the entity, and then you send your data and you receive at least the ID. Then when you are going to do a request of one, you do an HTTP GET. The path is going to be the same one with a plural, and you are going to have a slash and then the ID, whatever the ID it is. If it's a number or a string or UID, it doesn't really matter, but that is the ID of the item. And then you will receive the JSON back. And now if you do a request on money, you will do an HTTP GET on the same endpoint with a task with a S, and then you will have your own query parameter format for filter, limit, and so on, and that will return an array of data. And then for the update, depending on your strategy, you use put or patch, and then the same path where you have the task with the S, the ID, and then you send either the full data or the partial data. So that is a strategy that you have to agree with your API. And then eventually you receive the data, or you might receive just an OK signal or just the ID, depending on what you want to expose. And for the delete, very similar, you will expose an HTTP delete on the API and the ID. So that is REST in a nutshell. So now if we look at JSON-RPC, and JSON-RPC is a standard, you can find more information on JSON-RPC.org. And JSON-RPC is very close to REST, but you have only one endpoint. So it's a post, it's an HTTP post on some URI. So for example, for us, it's going to be API RPC, but it can be anything. And then you are going to send a JSON, and the JSON-RPC just defines the first level properties. And so the first one is going to be the ID, which is the RPC request ID, which is given by the client. It has nothing to do with the entity ID. And it can be a string, a num, or even null. And the contract is that the server has to send it back into the response of the request. So this way, there's also a way to batch comments, and then the client can find its duck like that. But this is very flexible, so you can pass one or empty string or null, and that will work fine if you don't want to use this feature. Then you have the method, and that is whatever name you want. So in our case, we are going to follow verb first, create, snake case, and then the entity. And in some cases, we might have some suffixes, but JSON-RPC doesn't dictate any kind of format, so you can follow whatever format you want. If you want to follow camel case or whatever, that is up to you. And then after you have params, which is just a map of your parameters that you want to pass to the function. So it really maps to a function call. Now JSON-RPC 1 allows to have an array of parameters, and JSON-RPC 2 added the object, which is what we want in our case. And then what is inside is up to us, the application developer. And then, as a response, when there's a success, the server will have to return this format, which is the first property will be the ID. Whatever the client sent over there, the server doesn't check it, just had to check that something is there. And then it has a result. And the format of the result belongs to the application, so it belongs to us. And then if there is an error, then we will receive a similar error with the same ID that were sent from the client, but now rather to have result, we have error. So the specifications say it's either or. If it's success, you have result. If it's an error, you have error. And then in the error format, the spec defines one level down, where you have a code that must be an integer. There's a reserved namespace from some standard errors, and then the rest is the application. And then you have the message, can be anything you want. In our case, it will be the enum variant name, client error. And then the data is optional, can be whatever the format the application wants. And in our case, it will contain the request ID and the detail, which will be property of our client enum, if there is some. Now, the great thing about this approach is that the method name map a function call. So for example, if we have list task, we just have list and task with a S, and that's it. And sometimes you might have something a little bit more specific, which doesn't really fit into a CRUD, like a lock task, which is we're locking a task and we don't want that to be only a property, but a specific call. And that is as simple as doing that. Because often this type of methods, you are going to have them ultimately, and they don't really fit into CRUD. And in fact, CRUD is often the beginning, but then you are going to probably need custom method as well. So in this way, HTTP is just a transport protocol, and then you have a clear format of the call and the responses. And that's it. This is basically JSON-RPC in a nutshell. And you can find more information on jasonrpc.org. And with that, we can go back to our code. So we are going to go to web, our module, and we are going to add a pub mode RPC. We are going to make it mode RPC because we are going to have some modules. We go into the file. We are going to create our module. We are going to reuse the web error and result for this module. That's completely fine. Eventually, we are going to create our mode task RPC over there. But for now, we are going to do some prep work. So first, we are going to create our RPC types. And we are going to have our JSON-RPC request body, which is our ID, method, and params. And so that is what we had over there. And for now, at this level, we just want to have the option of value, which is a JSON object, generic object. And then we'll do the final parsing at the RPC routing level. We're going to see that later. So we're going to import serialize and the value from JSON. So now that we have our params, we're going to have our params type. And for that, we're going to have different type of params, and we're going to categorize them. And that can grow over time, obviously. But the first one that we have at the high level is a params for create. So that will be all of the APIs that want to create something. So it's going to be over D, and that will be our data property. So we're not specifying data at all at this point. And then we're going to have a params for update. And the params for update in our signature, we're going to say it takes an ID and then the data. And then we're also going to have a params ID'd, which is for all of the APIs that just pass the ID. For example, the delete and the get. So for that, we're going to have a struct, which is params ID'd, and we don't need to have any data type on this one. So with this design, we're normalizing the params structure that we get, while we keep some of the properties like data flexible to be per function or per call. So that is already a good step. So now we can go back up and we're going to uncomment our mode task RPC. So now in the task RPC, we're going to use the CTX, the model manager, the result, and more that we'll do later. we are going to create our task, and that will return a result of task. So in our design, what we are deciding right now is to say the model controllers are going to be very granular, will only return ID on create, but we want our API to the outside world to return the data back. So that is obviously a design choice. Either way works, I'm just showing one way. The only important things again is to be consistent. We will be returning OK task. We're going to compute that later. That will take our CTX, our model manager, and our params. So right now the CTX and the model manager, since this function will be the end of line for CTX and model manager, we are consuming them and not taking the reference. This could be refactored later if that doesn't work. And then we have our params, which is from params for create. We can destructure our params. So that will extract the data from the params for create. So we're going to get a task for create into data. And now we have done all of the hard work in the model layer. So that was the goal of the model layer. So now you can do task BMC create with the CTX and the model manager and our data, which is our task for create. That will return the ID. And then we're going to get the task that has been created with the ID that we just got. And then we are returning it. And then that's it. Then we do the imports. And that's it. We did the create. So now for the list, that is going to be as simple. We don't need any params on this one for now. We're going to do the task BMC list, and that will return the vector of task that we are just going to return. Then later, in future episodes, we're going to see how we can add filtering, limit, offset, and order by over there. But that is for the next episode. But for now, that will work very well. And then we have the update task, which is the same thing. It's going to be the CTX, the model manager, and then the params, which will be params for update now, and with our data type, which is task for update. And right now we're making a call that our RPC API will return task. Again, that is completely optional. You can go either way. So we're going to destructure the ID and the data from the params argument, and then we're going to do task update, and we're going to do a task get. So this one is done, and now we're going to do the delete, and then the delete is going to be very similar. We're going to have the CTX and model manager. We're going to have our params now, which is going to be the params ID'd, and then we're going to destructure it, do the get, do the delete, and then return what has been deleted. So again, this is a type of API we want to expose, but if you don't want to return what has been deleted, it's completely valid as long as you are consistent. So that's it. We have the CRUD. Eventually, you could implement the get as well. We can do that later. But for now, that is a good starting point. So now we can go to our mod.rs. And what we need is to do the routing now. And it's a different routing because the first routing is on the URL, the path. And now we need to do a routing on the body because we need to get the method name from the body. So our RPC handler is going to return the Axum response. It's going to take the model manager as a state. It's going to take the CTX, and it's going to take the JSON of the RPC request. So what we have done in the task RPC are not the Axum handlers. They are more the RPC function handlers. And that is the Axum handlers, the endpoint of API/RPC. So that's why we're getting the RPC request at this level. We are going to do the imports. So the state obviously is from Axum. And then everything is kind of obvious. And the JSON is from Axum as well. Not for SQLX, is the one from Axum. And the response is from Axum response. So now that we have the route handlers, we'll be able to create our routes to follow the pattern that we had before. It's going to take our app state, and we're going to create our router, and it's going to be on RPC. The API will be added as we have done with the login, with the nest, so we don't need to specify API. And then obviously we have a with state because we want to have the model manager as a state. So we do the imports again. And now we're all set to do the routing. And we're going to use the same strategies that we use in other places. And it's going to be clearer later why. But we're going to have an async underscore RPC handler. And it's going to take the CTX, the model manager, and then the RPC rec. and it will return a JSON of value. So in our RPC handler right now, we're just going to do a pass-through. We're just going to call it like that. And because we have all the data from Axum, everything is fine. And then obviously it's an await, so we're going to do the await and the into response from Axum. So now in our underscore RPC handler, we are going to destructure our RPC request, that, and we're going to prefix everything with RPC. So like this, we have clean variable names. Then we're going to do our debug trace with our RPC method that now we have. And now the goal of this function will be to route by the method name and to get the result JSON that can be sent back. So for that, we're going to match on RPC method as string. And now we can give our task RPC method, and that will be our create, list, update, and delete. And obviously it can be many more as the API grows. And then we have to do our fallback, thank you Rust, and we're making sure that we're going to return an RPC method unknown if it's not found. So this way, if the things match, we're going to do the job, and if it doesn't, we'll have the log and we'll be able to debug our issues. Now we need to create this error on the web error. So we're going to add a section for RPC, and we're going to add a couple of them. So RPC method unknown, and then the RPC missing params, and then the RPC fail JSON params. Now if we see in our code now, we have this yellow line. And the reason why is because the compiler does not have enough to infer the type of result. So we're going to help it a little bit, and that is going to be value. Press save, and everything will be fine. Now that will become optional over time, but we don't want to have this kind of Clippy stuff everywhere, and Clippy is great, so I'm not complaining. So the first one we're going to implement, because it's the simplest, is going to be the list task. And that is because it doesn't have any params. Then we'll do the create task, and then we'll do a macro rules to be able to do everything in a concise and consistent way. So now we're going to go down, and we're going to have a code block here to go step by step. And that is a way that I code sometimes when I have chaining. I add a to-do like that, such as I don't have any compile error. And then I have a variable like let r for result, and then I'm starting my chain. So right now, I'm going to have a list task from our task RPC. I'm going to give the CTX and the model manager, and then we're going to do our await. So now we're going to see what we have. So we have a result of a vector of a task. That is a web result, but what we want is a value. So the next step is we're going to map our result into a to-value. And because you implement serialize, everything will be fine. Now we have our base body, Clippy, that is telling us that we have a redundant closure. And Clippy is always right, so we're going to have to-value. So now we have a result, which is a web result of a result of value. And that is a CRD result. So if we put a question mark, we are left with the CRD result of value. So we can put another question mark, and that will get our value. The problem is the web doesn't have yet the error from JSON. So we can add that. So we bring our web error. And the way that I like it is after my modules, I have external modules. And I'm going to do a CRD JSON, and I'm going to do the string right now. Again, that can be debatable, but right now at least that is a good way to start. And we're going to implement our from, very easy, from CRD JSON error to CRD JSON. And then we're going to do toString. And then that's it. We have that. And now we have our double question mark that works perfectly fine. And then once I have that, I remove the boilerplate code. Press save, it's going to reformat, and now it's clean and neat. So now we have our result JSON, which is our JSON-RPC result. So we're just going to do our body response, which is going to be our JSON, the RPC ID, whatever the client sent, and the result, which is whatever the result JSON was. And we can normalize it a little bit more, and we'll do that in future episodes, where the RPC handlers will return the command structs, such as we can have .data, for example, for everything that has a data and so on. But for now, we're going to have the raw data in the result property, which is going to be a very good start. So we're going to have OK, JSON, and we're going to have our body response. We import the JSON from CRD, this one, But the other one below with the uppercase is from Axum. Now, if we go to our main, we're going to remove our hello because we're not in the hello business anymore. And then we're going to uncomment our Rust RPC. And then we're going to uncomment our nest API Rust RPC. Press save. It's going to do some reformatting. So in this case, I'm going to have the module name RPC over there, and then everything should be fine. And now that we have that, we can bring our quick dev. We're going to remove our hello. The logoff is commented out. So that's good. It's for later. We can use it if we want to. And then we're going to do a list task. It's going to be a post on the API RPC. And the JSON will be the ID. So we're just going to set one. It doesn't have to be unique because we're not using it, but one is completely okay, or you can do null or whatever. It doesn't matter. And then we're going to have our method list task. And for this one, for now, we don't have any params. Then we make sure to execute it. So assuming you do a cargo run or you do a cargo watch on your server, now you can bring your quick dev terminal. We're going to do a cargo watch on our quick dev. We have the result. And obviously it's an empty array because there's nothing, but everything has been working pretty nicely. So that is already pretty cool. So now we're going to do the same thing for create. And for create is going to be a little bit bigger because now we have the params. So what we want to call is we want to call create task with our CTX and our model manager and with the params. But the params is a fully typed params. It's not the RPC value params. So we need to do some work just before. So for that, we're going to have our let params, and that will take our RPC params. So in this case, we want to make sure that there is a param. So we're going to turn it into an error, and we're going to do our RPC missing params. So that was the error that we created before. And then we're going to give our create task to string. So now what we have done is we made sure that we have a params, which is a JSON value. But we want to be task for create. So what we're going to do is we're going to do a from value of our JSON params. And then if it fails, we're going to return our error RPC fail JSON params. And we're going to give the error method. Later, we might want to capture the reason, but right now that is going to be fine. So we're going to import the from value and the create task. And that's it. Now we have params, which is task for create. And the reason why it's task for create is because the create task requires it, and so the compiler can trace it back over there. So now if we bring our quick dev and we're going to do a request for create, so for example, it's going to be our API RPC, the ID, create task, and then in our params, we have our data with our title task AA. And now, assuming you have your cargo watch on the server, we're going to rerun our cargo watch example. We could have press save, and voila. The last call was a list, and it does list this new task that we created. If we scroll back up, we're going to see that we have our create that created. And in fact, if we look at the backend, you can see that we have our list task, and then before we have our create task, and everything was successful. Okay, so that is pretty cool already. But now we have an issue. All of this boilerplate is kind of heavy to carry around because for update, we're going to have to do that and so on. And in fact, it's even worse because you will probably have more entities. So then carrying that for all of the entities is a lot of duplication. So there's many ways to solve this issue. And the strategies that we're going to choose for now is going to be the declarative macros. It's relatively simple, very convenient, and then after we can get fancier if we want. But that will go a long way to simplify and to scale our code. So we have two kinds of APIs right now. We have the one that have a params and the one that do not have a params like list task. And list task is a little bit the outlier for now, but we want to have a model that is flexible and doesn't require params. So for that, we are going to first do the simple case, which is going to be our list task. And so one thing that I like to do when I know that I'm going to land into macro rules territory is first I make the one-off work fine in my normal code, which is what we did for list task and create task. Then once I have my one-off, I copy them into my macro rules. That is a nice way here to get started, because if you start right away from the macro rules, it might get a little bit hard to debug sometime. So what we're going to do we're going to create our macro rules. We're going to call it exec for execute, RPC function. And the first arm will be the without params. And for that, it's going to take three expressions: the function, which is list task in this case, the CTX, which is exactly that, and then the model manager, which is also the model manager. And now we can take that, paste it there, and we're going to replace list task by $RPCFN, add the $sign to CTX, add the $sign to MM, and then we're going to take the name of our macro, and we're going to replace that with our macro list task CTX MM. We press save, and everything compiles. So right now we didn't save much. We exchanged one line for another line. It was not really a big deal. However, for the create, that is where we have all of this boilerplate that we don't want to repeat over and over again. So for that is going to be another arm. So we're going to take that and we're going to create an arm, which is going to be with param. We're going to add a fourth expression, which is going to be our RPC params. And so our goal is to be able to call our RPC function with the params. So we're going to take the boilerplate code that we had before in the create, paste it there. Now that will be $sign RPC params. And now for that name, which is a create task, obviously we cannot hard code it. There's a nice little trick, which is let RPC function name, and we're going to use stringify. And that we're going to give our $sign RPCFN. And now that we have that, we can put it there and there, paste it, and everything works nicely. So one reason why we're going with the macro rules for this kind of routing is because we have the await. And so you could build some sort of structure with async function pointer, but it gets kind of heavy and very dynamic in nature and so on. So right now, everything is statically typed, and it's actually very concise in our code. Now later, we can refactor that if that doesn't scale anymore. But often you can go a very long way with the macro rules. Okay, so next important detail is that we want to select the code block and add another set of braces because we want the macro to generate the braces as well. Because since that is not a one line, the match expects the braces. Okay, so now that we have that, we can test it out. So we're going to replace this whole code block with the RPC params. We're going to make it create task, press save, and we have a compile error, which is there. So now we can replace our update task as well. And we import the function for the delete, and we import the function. And then that's it. We have our CRUD. So now we're going to go to our quick dev, and we're going to do our update task with the ID 1000. So for now, we're going to hard code it, and then we're going to rename it task BB. And now we're also going to do a delete, and then we're going to hard code it. We're going to delete the second one, the 1001. It will fail at the first one, work on the second one, and then keep failing every time we run the quick dev again. So now that we have that, we're going to activate our delete. We're going to bring our terminal for the quick dev, and we're going to do our cargo watch over there. And so first we're going to have the task ID 1000 with task BB, which makes sense because it has been renamed. We're pressing save a second time. Now we do not get task ID 1001 because it has been deleted. And then we press a third time and we get our 1002 task AAA, which hasn't been renamed. So everything is working pretty nicely. And now if we scroll back up, we're going to see that we get a service error on the client side. Now if we bring our server-side terminal, we can see that this error mapped to the entity not found error. So everything is working pretty nicely. And then one thing that we're going to add right now is to say, what if we wanted to carry over this error to the client, such as the client knows that the entity was not found. So let's do that right now. So for that, we're going to bring our web error, and in our section client error, we're going to scroll down, we're going to open it, And that is the implementation where we are mapping the server error to the client status and the client error. So that is where we're going to have to add our map. And now first, what we're going to do is we're going to add a client error to this list. So we're going to add an entity not found. We're going to have the entity and then the ID. And then as I said before, in this case, for my client error, I like to have the uppercase snake case. So that's why we have the allow no camel case types up there. But that is obviously a personal preference. Now that we have that, we can go back up in our client status error, and we're going to add a section after our auth, which is going to be for model. And the nice aspect with Rust matching is that we can cherry pick what we match. So in this case, we are just going to care about the model error of the web error. And then inside it, we are going to match only the entity not found. Everything else will go to the fallback. And now we can return our tuple, status code bad request, our client entity not found, and we give our entity and then the ID. And in this case, we need to deref the ID because it's a reference of number. So now that we have that, we're creating the right client error. Now there's one thing that we didn't do in the Rust course, and that was to serialize the client error as JSON. We just had the name of the variant name in the JSON. So what we're going to add is serialize, and we're going to specify that the tag, which is a variant name, will be message, and the content, which is the content of each variant, will be detail. And now we can go to our middleware response map. That is where we are doing this transformation. At this level, we're going to update it actually to be more JSON-RPC. So we're going to get our client error. We're going to do a toValue. We're going to extract the message, extract the detail, making sure to import toValue. And then in our error, in message, we're going to output the message, which is a variant name. And in the data, we still want to have our UUID, so we're going to have rec_UUID, and we're going to put that. And again, in the JSON-RPC, the data is our format, it's optional, and it's our own schema. So that is what we're going to decide. And as a detail, we're going to have the detail, which is the content of the enum variant. So again, the message will be the variant name, just to be clear. So now that we have that, we're going to do our cargo watch on the quick dev. So we assume that we have the cargo watch on the server as well. And now we have the first one, TaskBB, second one, same thing. And third one, we have the 1002. And now, if we go back up to our delete, we have our error with our message, which is our variant name, the data, which has the request UUID, and the detail, which is the serialization of the content of the variant. And that's it. So now we have all the information on the client side that we want to pass from the server. And we are following the JSON-RPC. Now, actually, we are missing one thing of JSON-RPC, and that is the ID. So we have the error, but we don't have the ID. So that is what we want to do. And in fact, in the request log line, we also have the same kind of issue because when we have that on the server, we have the HTTP path, but we don't really know which method has been called in the request log line. So that is what you want to solve relatively early for your production application, because otherwise it's going to be kind of a black box. So for that, we're going to create an RPC info struct, which will have the ID and the method. And the ID, we're going to keep it open to option of value. And that is the main reason why we had this RPC handler wrapper over there, because now we're going to create the RPC info with the ID and the method that we get from the RPC request, making sure that we're cloning them. And then we're going to execute our RPC handler, but we need to store the RPC info into the response. So in this case, we're not going to store it in the request because we don't have it anymore. It's been parsed, it's gone. So we need to store it in the response. So we're going to still have our underscore RPC handler, So now we're going to get the response into a variable, which we're going to return. So that is our Axum response. And we're going to make it mute because before returning it, we're going to insert an extension, which is going to be our RPC info. So by doing that, now we're going to have the RPC info in the map response, such as we can use it for server login, our request logline, and for the eventual error that we need to send to the client. Now we're going to go to our middleware response map. We're going to extract our RPC info. So we make sure to import it. And so that will be an option of a reference of RPC info, which is what we want. And now in our log request function, when we're calling log request, we're going to pass it as an argument. And now we're going to go to the log. And in our request log line, we're going to add our RPC info. And it's going to be RPC ID, option of string, and RPC method, option of string. So in this case, we keep it very simple and very flat in our request log line, because it's going to be much simpler later to do some analytics or do some queries about it. So the more flat your request log line is, the better it is. So now, so we go back to the log request now. So we need to make sure that we're getting this one. So option of reference of RPC info. And now we need to make sure that when we're creating our request log line, we're having those. That is a little bit long because the ID is a value and the method is a string. There's a little bit more code in the ID side. So now that we have that, we have a very clean request log line with the RPC ID and the RPC method if there is one. And again, as I was saying before, everything is relatively flat except the error data. But even that could be a string as well. And so now we have solved our server-side request log. What we need to solve is now the client side. So making sure that we are sending the ID to the client to respect the JSON-RPC spec. And so here we are just sending the error. So we're going to add the ID property. And we're doing the as ref because we're using it below as well. And we're doing the clone. Okay, so now, assuming that we have our cargo watch on the server side, we're going to run our example. We're going to press save once, press save twice, and press save the third time. And we get our 1002, which makes sense. And now if we go back up, we see that we have our error with the RPC ID that we gave. And now if we bring the server side, we're going to see that in our request log line, we have our RPC method. So that is very important, such as you can query your log files to know what function is and everything. And then we have our RPC ID, which is on the server side is not as useful because that is an artifact of the client side. And that's it. This will conclude chapter 9, where we coded our JSON-based RPC API. This will also conclude this episode. And congratulations, we have coded about 1,200 lines of code and a robust foundation for a production web app backend or web service. Make sure to check the awesomeapp.dev Rust web app for more information. Until next one, happy coding.